Hello my dear students, how are you all? Welcome back to our YouTube channel Diksha Karnataka. I hope all of you are doing very good. Yes, today I am back with another session of your midterm revision for PU2. Today's chapter of discussion is what? Continuity and differentiability, right? So we have done so far matrices, we have done ITF and we have done relation and functions, right? 3 chapters revision are done with the questions as well. Today it's gonna be a longer session because the chapter is in demand, right? People are asking for it. Why? Sir, first of all, weightage is more. Secondly, chapter has a lot of topics, subtopics in it, so we have to cover up all the subtopics and we have to cover up questions on all the subtopics basically, okay, because we are revising for the examination, right? It's mathematics, so what is more important? How are you going to revise it? By solving problems, by making the practice. So that's why I've come up with a big practice session. It's going to be a longer session, so if you need to take a break before starting the session, take a break. If you have some other work to do or some small revision to do for other things, do it and then come back for the session, okay? Now one more thing, everything should be ready. Keep water with you. If you need to take a break, come back and see the session, the rest of the session, okay? So because I think it's going to be almost 35-40 questions we're going to solve together in this chapter, and I think after solving all these questions you will not need to revise anything else, because I have taken questions from asked by the boards in the respective supplement examinations. Maybe January there is an examination in May, so all the examinations are there, right? For these examinations they have asked the questions, so I have taken similar questions from there as well, and again from your basic board questions are also there. So I think this will be very helpful for you for your midterm revision for mathematics, right? So let's begin with the session. Take your pen and paper out, okay? Maintain the energy. Session will be longer, okay? For me to maintain the energy, I need you to be also maintaining the energy, okay? So maintain the energy, keep solving questions with me. If the question is getting lengthier, if you're thinking it's taking too much time, pause the video, solve by yourself, then come back and see the solution. Why that is required? Because if you have solved the question, if you have made your own mistakes while solving the problem, you'll be able to relate easily when I'm giving you the solutions over here, okay? So let's begin with the first question, which is going to be on continuity, So over here I've taken 3 sub questions in the same questions. So if you actually relate like this, there'll be more than 50 questions also, okay? But question wise I've taken I think 35 to 40 questions. But let's see first sub question of the first question, okay? What it says: examine the following for continuity. Means we have to check whether it's a continuous function or not, okay? Let's see. 1 upon x minus 5, rational function, okay? So at x equals to 5, how will the function look like? If you look at the first function, check this out. If at x equals to 5, how will the function look like? I think if this is line, what is the line? X equals to 5. What is this line? X equals to 5, okay? So think about it. If x goes to infinity, just think here. Over here in this function, y equals to 1 upon x minus 5 is there, right? Correct? If x goes to infinity, what will happen to infinity minus 5? Remains infinity only. And what is going to be 1 by infinity? 0, okay? So means it will approach to 0. So it will be somewhere here. Alright, what about when x is approaching 5? When x is 5, can x be 5 actually? No sir, x is not equal to 5. But what if it is very close to 5? Not 5, but it is close to 5. What will happen? It will become almost 0, it will become infinity. So basically after 5, means after x equals to 5, the graph will look like this or not? Yes, think about it. When x goes to infinity, the y value is tending to 0. So I'll write it here. When x tends to what? Infinity, y value is tending to what? 0. And when x tends to what? 5. From which side? From the positive side, means 5.111 or 5.000001. I'm saying that. I'm not saying before 5, after 5, okay? So when x tends to 5.000001, what happens to this value? This will be a positive value, but positive what? Positive 0, okay? Means it will not be a 0. Sir, how can 0 be positive? Not a 0, 0.00000001, but positive, okay? What will become that? That will become infinity. But what type of infinity? Positive infinity, sir. Yes or no? Okay. Now think about when x tends to negative infinity, this will become simply like this, right? Like this, right? Okay. Same thing if I do here. X tends to negative infinity, it will be y tending to 0. Okay. Y tending to 0. And what about this? When x tends to 5 from the negative side, means if I am moving to x from the left hand side, what will happen to this? It will be a negative number. Why sir? 4.999999 like that. Minus 5 will be minus 0.00001 like that, okay? So it will become what? y will tend to negative of infinity. So that this is my function, this is what? Negative infinity. Now if you look at this function at x equals to 5, is it continuous? No sir. So this is going to be not continuous or discontinuous, okay? Not continuous or discontinuous at x equals to 5. Everywhere else it is continuous, right? At x equals to 5, not continuous, okay? Second problem, fx equals to x square minus 25 upon, okay, upon x plus 5. So let me write this here. Y equals to x square minus 25 upon what bacha? X plus 5, okay? Am I right? Yes. Now, if the question was given like this only, then it would have been a discontinuous function, okay? We have to see, okay? But they have already mentioned here, x is not equal to minus 5. If it is not equal to minus 5 means what? Means I can factorize it. You'll see how. So if I factorize it, what are you gonna get? X minus 5 and x plus 5, okay? Upon x plus 5. Now please check here. If this was not given, it means this can be 0 at minus 5. If this is not given, then I can take this at minus 5 will be 0. Can I cancel 0 and 0? You cannot. But since it is not 0, I can cancel this and this, right? So what is the function now? Y equals to x minus 5. Yes or no? Yes or no? Yes sir. Okay. Now this function will be what? Defined, right? This function, if you find the left hand limit, how you find left hand limit, bacha? By putting x as what? 5 from the left hand side. How much that will be? 0 only, right? 0 only. If you put 5, if you put left hand limit like this, limit of the function x minus 5, when you move to x from what? Which side? Move to 5 from which side? Negative side, okay? What will this be? This will transform into limit 5 minus h minus 5, okay? Where h tends to 0, yes or no? How much is that going to be? Check here, 5 and 5 will cancel, minus h when 0 is nothing but 0, okay? Same if you do for RHL also, what will happen? You write like this, limit, I'm writing from here, 5 plus h minus what? Minus what? Minus 5 upon when h tends to 0, yes or no? That's how we write it, no? A minus h we write for LHL and a plus h we write for RHL. Now if you check here again, it goes cancelled, and what is left now? Only h, where h tending to 0 means equal to 0, okay? So both LHL and RHL are equal, 0 and 0, okay? And if you put in this function value at 5, what is the value at this 5? What is the y value at not 0, forgive me, 5. Y value at 5, what is that value? What is it? 0 only. 0 only, okay? It means now check here, left hand limit, right hand limit are equal, means limit exists and limit value is 0, function's value is also 0, okay? Then what happens? The function is continuous. The function is continuous, okay? Continuous. Now if you are not able to recall this concept, understand this. For continuity, bacha, this is a conceptual remark, please make a note of it. For continuity, what happens is, for continuity, okay, for continuity, what happens? Your limit should exist. When can I say the limit exists? When LHL and RHL are equal. So basically, your LHL should be equal to your RHL, should be equal to your function value at that point. RHL at A, LHL at A should be equal to function's value at that point of time, okay? So same thing we did here. Please check. LHL at A, okay, at 5 is how much? Is 0, and RHL is also what, bacha? 1 second, I can rewrite this. It looks 0 as a part of here. I'll write this over here only, 0. My LHL is 0, RHL is also 0, and function value is also 0. It means the condition is satisfied, so I can say the function is continuous. What about this one? Fx equals to mod of x minus 5. Third one I'm moving to. Fx equals to, or y equals to mod of x minus 5. Okay, whenever you see mod, no, it's easy to draw what? Graph. So let's draw the graph. I can write this function as first I can get this function from y equal to mod x and move the function towards right. Think about it. This is what? Minus 5 is what? Transformation. If I am moving minus 5 units, if I am transforming by minus 5 units, it means what? Graph moves towards, graph of the mod x move towards right by 5 units. So first you will draw the graph of this. This is the mod x graph. Yes or no? Y equal to mod x graph is this. Moving this by 5 units means what? I will have another graph over here. over here at 5. Okay, this is the curve for y equals to mod of x minus 5. If you don't agree with me, put x equals to 5. When you put x equals to 5, what are you going to get? 5 minus 5 will be 0. So at 5, what is the value of the function? 0. Okay, great. Chaliye. Now think over here. So this is the curve. Is it continuous at all the place? Look at the graph. Always continuous, sir. Always continuous, sir. Okay, in the domain it's always continuous. So far we got for the first one is not continuous at 5, continuous and always continuous. Okay, moving on. Okay, see, we saw 3 questions with 3 different approach, right? We saw 3 questions with 3. First one we saw with what? With the graph, we drew the graph. Second one with the limits, and third one simply by looking at the graph. Okay, nothing else. Find all the points of discontinuity. Okay, how can we check the continuity? LHL or RHL? Quickly find it. Chaliye, jaldi karenge. LHL, how much is this going to be? Please check here. For LHL, I will check the function before 2. Before 2 is what? 2x plus 3. So put that in the function at 2. So what will this be? There's no, so I'll write it as limit of fx when x tends to 2 from the negative side. Simply write it over here. Will become what? 2 times of 2 plus 3. How much is that? 7 or not? 7 or not? 7, sir. What about RHL? Please check the RHL. What is RHL? So limit of fx when x tends to 2 plus, okay, will become but 2 times of 2 minus 1, sorry, not minus 1, minus 3, minus 3, so 1. Sir, why like this? Because check here, on the right side of 2, on the left, on this side of 2, right side of 2, I have the function defined as 2x minus 3, so I'll use that function in place of fx, okay. Whereas before the x, before the 2, means on the left hand side, I have the different function 2x plus 3. So obviously the function is not defined. What is it? Not continuous. So what is the point of discontinuity? So point of discontinuity is what? Is x equals to 2. At x equals to 2, the function is discontinuous. If you want to see, look at the graph. You'll get this function to be like this and like this. Okay, yes, if this is my point x equals to 2, please check at 2 what is the value? 1, sir. So this is the value 1, sir. Okay, and what is this value? This is 7, sir. This is 7. Okay, because what is the value here? Please, at 2, before, like, left side of the 2, what is the function value? What is the function value? 7. Right of 2, what is the function value? 1. So that's why 2 parts. Okay, so if you see here, before and after continuous, but only at the point 2 discontinuous. Okay, at point 2 you have break in the graph, so discontinuous. Okay, let's move on to the question number 3. All right, find all points of discontinuity. Points of discontinuity again. Let's find the LHL value. Okay, find the LHL value. At point 1 we can find. Okay, at point 1 we can find, because after 1 what will happen? This function will be same, no, straight line. Okay, it means it will be continuous only. Before also it's going to be a curve, again continuous only. Okay, so we are checking at only one y, because the function is defined at 1 in 2 different ways. Okay, there's a break in the function. All right, for that way the function is defined over here. That's why I'm checking only for 1. If you, let's say, check for 2, what is the 2 at x equals to 2? What is going to be the function? If you have this doubt, sir, why I'm checking only for 1, check x for 2. I'll take which one? Can I take this one? No, sir, it is x less than 1. I have to take this one only. X plus 1 is what? It's a straight line, sir. Yes or no? Straight line, sir. So it will be what? What will this be? Tell me. It will be a line. Okay, straight line is always continuous, no? Yes, same way this will be a curve. Curve is always continuous again. So that's why we are not checking for other values, only at 1 we are checking, bacha. I hope this is clear. Okay, I hope this is clear. Okay, chaliye. Now check for 1 at 1. Take the LHL value. How will I write LHL? Is not simply I can write it like this. So limit fx when x tends to what? 1 from the negative side. Correct? LHL is written like this. What's the function from the to x square plus 1? X square plus 1, and what I'm going to replace this with 1. Okay, with 1. So I'm going to replace this x with 1. Please check. So it will become 1 square. Okay, how much is that? Simply 2. Check the RHL now. Please check the RHL now. Same way, limit of fx we'll write here. Limit of fx when x tends to what? 1. But from where? From the right hand side, right? From the right hand side. What will this be? Which function? X plus 1, right? So I can write what? 1 plus 1. How much is that? 2 again. So what is the function value? What is the f of 1? Check here. Equality is holding here. Equality is greater than equal to, no? So I have to check this function. F of 1 will be what? 1 plus 1 again, which is again what? 2. So what we are getting? F of 1 is equal to LHL equals to RHL. It means what? It means continuous at x equals to 1. Okay. Now, before and after, before 1 there is no point of discontinuity because it's a simple curve, and after also it's a straight line, so no point of discontinuity. So we had only doubt at 1. Even at 1 it is coming at continuous, means we can say no point of discontinuity. Simple enough? Simple enough? Yes sir. Okay, chaliye. All right, what about this? Okay, so I will not solve this question using what? Using this approach, finding LHL and RHL. You can do that. I'll let you know how to find it. Obviously function's value is what? Function's value at 0 is what, bacha? Check here. Simply 0. X equals to 0. What is the function value? 0. Okay, how will you find LHL and RHL? Using this part. Why sir? Not equal to 0 means what? X less than 0 also and x greater than 0 also. Something not equal to 0 means what? Either less than or greater than. So not equal to 0 means less than and or greater than. Means for LHL also or RHL also you will use this which function? Mod x by x. Okay? Okay or not? But right now let me see. I'll show you in the graph. It is such a function. So at x equals to 0, what is the graph? Over here. Yes or no? At x equals to 0, function, I'm drawing the graph of the function. Okay? At x equals to 0, what is the graph? 0. So I put it here. Now tell me, if I take x equals to any positive number, let's say I take 0.01. Okay? I have to apply what, bacha? Apply mod. Divide by what? 0.01. How much is that? So 0.01 by 0.0. How much is that? Simply 1. Same way if I take any number, no. So on the right side of 0, please understand, on the right side of 0, this will be positive, this will be positive again. Both. So what's the value of the function? Positive. So this is 1. Okay, please check. So on the right of this, again, what is it? At 0 it is open, but on the right it is always 1. Okay, always 1. If I take 2.5, it will be 2.5 by 2.5. Yes or no? 2.5 by 2.5. Okay, so it will cancel each other. Again 1 will come. What about before 0? It will be simply minus 1. You will not agree with me? Yes, it will be simply minus 1. How sir? Check. Same value you can check. Minus 0.01 in the mod divided by minus 0.01. How much is that, bacha? Simply 0.01 upon minus 0.01. Cancel it. How much is left? Minus 1. Same thing. Now check. At the point x equals to 0, is there a discontinuity or not? There is, right? Okay. Why sir? Because this is my LHL and this will be my RHL. Are they equal to each other? No sir. So means the point of discontinuity is what, bacha? X equals to 0. This is my answer. Okay. Please write it here. X equals to 0. I am focusing on giving you understanding. I don't want to just come here and solve all the steps. I want to explain things to you. Okay. So if you are looking for, I am trying to write all the steps whenever I am doing things. But if you are not able to relate with all the steps, follow NCERT steps. Follow your textbook steps. For any particular question, the kind of questions is solved in the solved examples. Okay. Follow the exact same steps. Why sir? Because steps carries marks, bacha. Steps carries marks. Okay. So make sure that you are following all the steps. Over here I am trying to explain your theories. Okay. Chaliye. Moving on. Okay. Moving on. This question, so again we can solve using the graph approach. Yes or no? After 0, what is the function graph? Y equal to x, right? So straight line. Before 0, curve. What curve? Parabolic curve, right? Please understand this. Before 0, x square. So parabolic curve, this is my y equals to x square. What is this? Y equal to x. Is there a point of discontinuity? No sir, at x equal to 0, check here. x0 is 0, 0 square is also 0. So there is no point of discontinuity. Okay. So continuous everywhere. Continuous in domain. Obviously, whenever we talk about continuity, what do we talk about, bacha? We talk with respect to domain only. So first of all, first thing was the limit should exist and should be equal to the function value at that particular point, and we'll talk about continuity only in the domain. Okay, because limit also talks about only in domain. No, if you have revised limits is also defined in domain only. We don't go out of the domain and define it. That's why if you remember the first question, I wrote it as x not equal to minus 5. This means what? Minus 5 is not part of the domain. That's why even though minus 5 is not defined, but it is not part of the domain. So that's why we were able to relate there. Okay, limits is defined in only domain. So all of this function will be defined for, all these properties will be defined for only in the domain. Okay, moving on. Okay, this problem. Okay, they're saying that f and g are continuous. What is the meaning of continuous means? What is the meaning of continuous? Continuous means that, one second, continuous means that, check here, it means limit for the function fx when x tends to c, right? What is it? Simply equal to f of c. Correct, na? Limit when it becomes equal to the function's value. So why not writing LHL and RHL? I don't have to write, because whenever LHL and RHL are equal, it means limit exists. That's the definition of limits. How will you say that limit exists? If the LHL and RHL are equal to each other. So if I'm writing just directly limit, that is enough, right? So limit value equals to function's value. Okay, that is what it means. It means it is continuous. Same way for gx to be continuous. Okay, I can write this as limit of the function gx when x tends to c bacha is equal to what? gc. This is my given condition. What is this? These two are given situations, okay, or given conditions. Yes or no? Yes, sir. Now what about the first one? F plus g is continuous. Check here. So if I apply the limit on both sides, what I'm getting, please check. I'm getting limit of f plus g when x tends to what? c. I can separate the limits. You know that? I can separate the limits. I'll get what, bacha? Limit of f x tends to c, fx is there, and limit of gx when x tends to c. You know this is what? What is this? This is nothing but f of c. And what is this? G of c. So basically we started from the limit part. If this is a function, okay, let's function p, then function's limit is equal to sum of the functions. Okay, okay, like this. Please check here. So what I'm getting is, I'm getting limit of f plus g x tends to c is equals to f plus g at c. Yes or no? This combination at c, when this is true, means what? It is valid, right? It means this is f of f plus g is continuous. F plus g is continuous. Same way I can do for f minus g, f into g, and f by g. Yes or no? Okay, provided g by c, gc is not equal to 0. I'll do for f into g once. F minus g again you can do the same way. Put it here, minus sign, you'll get it again. So f into g, let me do it. F into g. You have to check for f into g. So first of all, let's apply the limit. So limit of f times of g when x tends to c will be given by what? Limit of fx when x tends to c multiplied with limit of gx when x tends to c. Yes or no? Yes or no? I can write this as what, bacha? F of c times of g of c. Okay, this means what? This means, what does this mean? This means continuous. Yes or no? Product of means limit of the product is equal to product of the numbers at that value. What was the continuity? Continuity was limit value should be equals to what? Should be equal to what? The value of the function at that point. Okay, so limit value of what? F into g is equals to the function's value at f into g. So it means continuous. Okay, yes, same way I can do for product also, sorry, quotient also, and subtraction also. I hope you were able to do it. I hope, please do it. Okay, so these two, you please do it from your side. This one and this one. Okay, solve it. चलिए आगे बढ़ते हैं. Now, question number 7. Question number 7, sir. Find all the points of discontinuity of the greatest integer function defined by f of x given by, okay, simply this y equals to greatest integer of x. That's what the question is. Okay, asking us to find the point of discontinuity. The points of discontinuity. Okay, You should know the curve of this. What does it mean? Greatest integer function. Means for a function, let's say defined like this, y equals to 1.5. What is the answer? 1. Y equal to 17 to 8. What is the answer? 17. Y equals to minus 2.5. What is the answer? Okay. Okay. Let me draw the graph. Okay. From there only you'll understand everything. This is the curve. Okay. For what? This is my Cartesian plane. X, Y. Please check. 0, 1 open. Okay. Okay. At 1 what is happening? 1, 2 open. Okay, this is 1, right? This is 2. At 2, 2, and it's again open at 3. Same way. Same way. Please check here. At 0 it is closed here. Okay. What about this point? At minus 1 open, because it's equals to what? Minus 1 here. Okay. Again what? Open, close here, open and close here. What is this? Minus 2. What is this? Minus 3. This is again minus 1, minus 2 and minus 3. How much is this? 1 and 2. 1 and 2. Okay. Alright. Okay. Please check. Please check. 1 second. So if you look at this value, at every point where it is integer, minus 1, minus 2, minus 3 or 1, 2, 3, what is happening? There is a break in the function. Yes or no? First break. Break. Here also is there a break. Here also there is a break. So everywhere at integer there is a break in the function. Means discontinuity exists. Discontinuity exists at all integers. For x belonging to all integers z, okay, the function is discontinuous. All integers, what is the function? Discontinuous, sir. Discontinuous, sir. Okay, because at 1 it is 1 and before 1 it is what? Right before 1 what is it? Right before means if I write like this, let's say if I check for 1, what's the answer? 1. Write like this, 0.09999. What is the answer? 0. Write like this. Okay, 1.1 or 1.000001. Okay, what's the answer for this? Again 1. So left hand limit is what? 1. Right hand limit is, sorry, left hand limit is 0, right hand limit is 1. Okay, so it means the function is discontinuous. The function is discontinuous. The left hand limit, okay, the left hand limit is LHL is not equal to RHL when, sir? When x is always integer. Since LHL and RHL are not equal means limit does not exist. If the limit does not exist means how will the continuity part exist? Okay, because what is the continuity definition? Limit should be equal to the function's value at that point. Okay, moving on. Again, what is this given as? X minus greatest integer of x. So function is defined as y equals to x minus greatest integer of x. Okay, okay, means this is only integral part. This is only integral part, right? What is the result of this? Result of this is only integer. Think about it. Okay, so basically if I'm writing let's say 1.75, how will I write like this? How will I write this? I write it as 1 plus 0.75. Yes or no? Okay, so basically this is my x, okay, any number x, and this is my greatest integer of x, okay, and this represents a function called as, if you remember, fractional part, called as fractional part, or also called as, simply I can write it as fractional part of x. So think about it, whenever I'm talking about fractional part, it will be a number, it will be a decimal less than what? Always 1. Yes or no? Always 1. So please check here. If I draw the curve for this also, how will the curve look like? Start from 0, goes till 1, open. At 1 what will happen? It will be 0. Again goes till 1, goes to 1. Again starts from 0, goes to 1. Starts from 0, goes to 1, and keep going like this over this other side also. Start from 0, goes till 1, start from 0 and goes till 1. I'll explain it to you, don't worry. So basically what I'm trying to say, if I write like this, fractional part of 1 will be what, bacha? Tell me. It will be simply 0. Okay, means if you check at integer value, if you check at an integer value over here, this is 1, this is 0, 1 and 2, check at 2, add 2, what is the value? Add 2, what is it? Add 2, it is 0. So means on the 2 right hand side, which is RHL, what's the function value? 0. And before 2, what is it? 2 minus, what is it? Close to 1. Close to 1. It is not 1 but close to 1. Okay, is it equal to each other? Is it equal to each other? No, sir. I can see from the graph also, there's a break at integers. So if I write like this, minus 2, minus 1, 0, 1, 2, 3. At every integral value, every integer value, what is happening to the function? The function is getting a break in the graph. Means discontinuous. Answer is, please write here answer, discontinuous at, okay, x belonging to integers. Okay, why? Because limit does not exist. What is the answer again? Limit does not exist. LHN and RHL are not equal, because right after 2, what is the answer? 0. Right before 2, what is the answer? Think about it. What's the value over here? 0.9999, almost, what is it? Almost 1, no? And right after, what is the value over here? 0.000000001. So is it equal? Is it equal? No, sir. It means left hand limit and right hand limit are not equal to each other. Also, one more thing, it's not 0.001, it will always keep going, okay? Otherwise, this is a defined function. Right hand limit, the value right after 2 is not, right after 0 is not defined. It's just, it will never end, okay? Chali, moving on. Moving on, sir. Question number 9. Find the values of k. Good question. See, January 16, January 18, January 23. Okay, they keep asking like this. Okay, May 2014. What is the question? Find the values of k so that function f is continuous. Means over here they have given the function is continuous. What it means? This is a given condition. Means what? Means basically LHL is existing, RS is also existing. They are equal and it's equals to function's value at the same point. That's what they are saying. Okay, chali. Let's check for the first one. Let's check for the first one. They're saying that kx square when x is less than or equal to 2. Less than or equal to 2 means I can take the equality sign. So what's the, tell me what is the function value at 2? Less than equal to is there, right? So I can take f of 2 as kx square simply. So it will become what? K times of 2 square. Right, now I'm writing at 2. So 2 square. How much is that going to be? Simply 4k. Yes, sir. Yes, yes. What about RHL? What about RHL? Sir, why not LHL? Because they're saying that it's continuous. So both are actually equal. It's given it is equal. So I don't have to take find both the values. No, I can find only one value. I can find RHL also. Check here, RHL. What is my RHL? I have to look for what value? More than 2. RHL means what? 2 from the positive side. Means more than 2. Is there a variable here? No. Simply what is the answer? So RHL is given simply as 3. RHL is given simply as 3. Okay. So my RHL is 3. Okay, now check here. For the continuity, what happens? RHL should be equal to the function value. So 3 should be equal to 4k. So what is my k value? Check here. 3 by 4. First is done. For it to be continuous, RHL should be equal to the function's value. So from k, there we get k equals to 3 by 4. Simple. Second problem. Let's see the second one. K cos x upon pi minus 2x. Let me write it. K cos x upon pi minus 2x. Okay. Okay, sir. And this is 3. This is 3. This is a function defined like this. Okay. Sorry. At pi by 2. Talking with respect to what? This is not equal to pi by 2. And this is pi by 2. I have already explained you not equal to means less than also is true and greater than also is true. Means for less than and greater than, I'll use this function, and for equal to, I'll use this function. Okay, I'll use this function. Now check the continuity. I'll find what? Let me find the LHL over here. Let me find LHL over here. So if I'm finding LHL, limit of fx when x tends to what? Pi by 2 from the negative side. Yes, I can rewrite this as limit of f of what? Tell me, pi by 2 minus h, where h tends to which from which side? Simply 0. Correct, na? I've transformed this into left hand limit formula that we use. Okay, this is the formula a minus h. For left hand limit we use a minus h. For RHL we use a plus h. So this is a, right? A, so pi by 2 minus h. So put it here in the function. I'll get limit h tends to 0. Okay, what is this? So k will remain as it is, cos of pi by 2 minus h upon pi minus 2 times of pi by 2 minus h. Am I right? Please check. I have replaced x by again pi by 2 minus h. Okay. Please see now. Next step. Limit h tends to 0. K. Cos of 90 minus theta. Cos 90 minus theta is simply sin theta, sir. So sin h. Okay. Sin. This is k. And how much is going to be? Pi minus 2 into minus pi by 2 is how much? Simply pi. 2 into minus pi by 2. Minus 2 into pi by 2 is simply pi. And minus into minus will become plus 2h. Minus into minus plus 2 into h is 2h. Okay. Check here. Pi and pi goes out. What is this function now? So it's going to be limit k times of sin h upon h where h tends to 0. Sin h upon 2h when h tends to 0. Now please look at this bracket. What is the limit value of this sin h upon h when h tends to 0? Is simply 1, sir. So what I'm going to get? K by 2, my constant value, and this will become what? 1. So what is my LHL value? Simply k by 2. Yes or no? Simply k by 2. What is my function value? For it to be continuous, we know this, right? We know this. What is it, Bicha? Not visible, sir. Let me rewrite this again. Okay. We know that for it to be continuous, my LHL should be equal to what? Function value at pi by 2. What is my LHL? K by 2. What is the function value at pi by 2? 3. Put here 3. What is K value? 6. So if this question is asked, only one part will be asked for a 4 mark or 5 mark question. Okay, it will be a 5 mark, it will be a big question. Okay, and it's going to be a very, very valuable question. I hope you understood. What is the answer for K? First one is 3 by 4 and next one is 6. Okay, they will not ask you both parts. Okay, I have taken both parts to explain you different type of question. They'll ask you only one question, either this part or this part. Okay, either similar to this or similar to that. Okay, chaliye. Question number 10. So that the function defined by fx equals to cos of x is continuous function. Okay, let's do it. This is a very simple problem. Simply y equals to cos x, the mod. So first do one thing. Draw the graph of y equals to cos x. Okay, we have to analyze the graph. So let's check. Cos x will look like this. Yes or no? Yes or no? Yes. And what is they are saying? Modulus of this. Modulus means what? All the negative part will go on the positive side. So this is it. Okay. This is your curve. So what is my final answer? What's my final answer? Please check here. This is my final answer. So this doesn't look like equal to 1. Okay. So I can redraw it. Please check. Okay, this is incorrect figure also because it is cos, no, it is sin actually. Cos will be what? Passing through 1, right? Cos will be passing through 1. It will not be passing through 0. So but I think you get the point. Okay, this is my graph. Please check here because what is the cos 0? Cos 0 is 1. Okay, that was the mod of sin x graph. This is mod of cos x graph. Property remains same. You draw the cos x graph. Okay, you draw the cos x graph like this. Okay, cos x graph like this, and then take this negative value on the top like this. Okay, same thing I've done here. Okay, this is by mod of cos x. Is there a point of discontinuity? Please check here. No, sir, it's a continuous function. No, there's no drop, there's no gap in the graph, so it is continuous function. It is a continuous function everywhere. Okay, let's move on. Okay, now so let's see. Now we have to check about some differentiations. So let's see some formulas first before going into it. So let me revise all the formulas, whatever is there in differentiation. After that, what we're going to do, we'll solve some questions on the differentiation. So we have completed what now? We have completed solved how many questions? 10 questions we have solved on the continuity part. Okay, we have taken a variety of questions where we have to check whether the continuity is there now. there or not. We also checked the question where there was a discontinuity. We also found the point of discontinuity. Next, what we did, we solved the question where we had to find the variable k. Okay, so all the values, different variety of questions in the continuity we have considered. Moving on to differentiation. So start from the formula. Just a recollection of all the formulas. Okay. So differentiation of, that's how we write, that's the symbol of differentiation, right? Symbol of differentiation, x power n. First one, x power n. Now even there is a constant, doesn't matter, you can take the constant outside. Okay, what will this be? Simply n power x power n minus 1. N times of x power n minus 1. First formula is this. Okay, second one, take this ln x. What is the answer for this? Simply 1 by x. What if it is log x, differentiation of log x. This will be what? 1 by x ln a. 1 by x ln a. Okay, what next? D by dx of, okay, d by dx of e power x will be same as it is, e power x. Okay, so these are some basics formula. Exponential, sorry, yeah, in the power form when is given, exponential function given like this, ln, this is polynomial function. Okay, polynomial function x power n, so n of x times n times of x power n minus 1. Logarithmic function when there is a natural log, normal log, what we will have? 1 by x ln a. What is n a here? The base. Okay, d by dx e power x as e power x. Okay, now we look into what the most used ones are trigonometric functions. So let's look for trigonometric functions. So we'll recall these formulas also. D by dx of sin x. How much is this? Tell me. So it is going to be cos x. What is for cos x? For cos x going to be minus sin x. Okay. What about tan x? Tan x will be what? Sec square x. Okay. What about sec x? Sec x will be sec x and tan x, right? For sec x we have sec x into tan x. Okay, what about anything else left? Cosec x, right? 1 2 3 4 5. Okay, anything I'm missing cot, I'll do it. This will become what? Minus for cosec x we have minus cosec x and cot x. Okay, what is the next one? Cot x. So please check here. Differentiation of cot x will be what, bacha? What will this be? Simply minus cosec x square, cosec square x. Okay, now what? So first we did the normal ones, logarithmic, exponential, and so I hope you can see this. Please see this. I hope see. So first formula, first, second, third, fourth, fifth, sixth, seventh, eighth, ninth. Okay, let's check here. 10th, and next one will be what? I'm moving on to ITF now. Okay, let's do for ITF also, because we'll use in the question in the section only. So let's write it down. D of dx of what? First one is sine inverse of x. How much is this answer? I hope you know this. 1 upon root of 1 minus x square. 1 upon root of 1 minus x square. What about 12th one? D by dx of what? Cos inverse x. Same thing you'll do. Same thing you'll do what? 1 upon with the minus sign 1 minus x square. So for cos inverse, just introduce a minus sign in the numerator. Okay. The next one is, what is the next one? D by dx of tan inverse of x. How much is that, bacha? Please tell me. How much is this? Okay, this is going to be simply 1 upon 1 plus x square. Okay. Now, for cot, what will happen? Simply make it minus. So if you are writing for, let's say, if you are writing for cot inverse, just make a minus sign here. Okay. This is like this. So, okay. What next is there? So for cosec inverse, what will be? Please check. So for sec inverse. Okay, I can write this as 1 upon mod of x times of x square minus 1. Okay, x square minus 1. This is for second inverse. For cosec inverse, what will happen? Just add a minus sign over in the numerator. For the cosec inverse, add a minus sign over here. Alright. So I think this is enough for your formulas for differentiation rules. We also have some theorems. We also have some theorems or some rules which we use to solve questions in differentiation. What is the first one? Simplest ever, product rule, if you remember. Product rule. What's product rule? If you have differentiation of what? uv, okay. What is it going to be? Keep u as it is, differentiate v. Keep v as it is, differentiate u. Okay. Next one, excuse me. Quotient rule. Quotient rule is what? So d by dx of what? If it is u by v, what are you going to do first? So differentiate u, keep v as it is, minus keep u as it is and differentiate v, divide by v square. Quotient rule. The denominator will be squared in over here, and you will do for the first u derivative, keep v as it is, take a minus sign, keep u as it is and take the derivative of v. Okay. Third one. Chain rule, again very important. Chain rule. Okay. So what happens is, if there is a function, let's say u of v is not u into v. If it is not, let's say, let me write it like this: f of gx, then what we're going to do? So first we'll take derivative of f dash of gx, okay, and then we'll continue with this. What we'll continue with g dash of x, okay, and then what we're going to do? Differentiate x also, okay, differentiate x also. So we're going to differentiate x also. So first the first function, then the function which is inside the function, then the polynomial or whatever is coming for x, you have to differentiate that part also. Chain rule, okay. It keeps going on. If it is 3 function, we'll do it to 3 times. 4 function, 4 times. Keeps going on the chain. That's why I call that chain rule, okay. These are the fundamental rules and theorem that we have to see. I'll show you from the beginning again one more time. This is few rules. If you want to have a look, I hope this is clear, okay. Okay, let me move on to the next set of questions, which is on differentiation. Okay, was this going to be differentiate cos power 6x? Okay, I will use what? I have to use chain rule again here. Please check. Why, sir? Because this is going to be a polynomial function and a trigonometric function. So if I write like this, y equals to cos 6x like this. Okay, what is going to be? Y dash will be what, bacha? Tell me. Y dash will be simply for 6 times of cos 5x. Why, sir? Because 6 minus 1 is 5. 6 minus 1 is 5 times what? Cos ka differentiation of cos. What's my final answer? 6 cos 5x and minus sin x. What's the final answer? Minus 6 sin x cos 5x. Cos 5 power x. Cos power 5x. Final answer. Okay. This is not alpha, this is x. This is not alpha, this is x, bacha. Okay, simple enough. Moving on. Question number 12. Okay. Again, a very simple question. Differentiate this function given in the form of polynomial. Let me write it like this. So I can write it like this here. Y equals to what? I can take this in the numerator. It will become what? Please check. 2x square plus 4 power. What is the root? What is the power right now? Root is there, means 1 by 2. In denominator means minus 1 by 2. So write it as minus 1 by 2. Now differentiate this with x. I'll take what? Y dash will be equal to minus 1 by 2 will come here, and this will be 2x square plus 4 minus 1 by 2 minus 1. Yes, right? This is the n, right? This is my n right now. N minus 1 is the formula. N times of, what is the formula? Remember this? N times of x power n minus 1, right? So n comes in front. X is the whole thing, this power minus 1. So that's the same thing I've written here. And then is it enough? No. I have to differentiate this also. Differentiate what, bacha? The bracket. Yes or no? Yes, sir. How much is that? Minus 1 by 2. How much is that? 2x square plus 4. What is this? Minus 1 by 2 minus 1. Simply minus 3 by 2. okay, and how much is this? 2 times of 2 will be 4x plus 0. Why 0, sir? For any constant, differentiation is 0, okay? For any constant, differentiation is 0. I missed that. Please remember it. For any constant, differentiation is always 0, okay? So what is my final answer? Please check here. Minus 1 by 2. I can write here 4x first. It's multiplication, right? And this is going to be simply what? 1 upon what? 2x square plus 4 to the power what? 3 by 2, okay? So if you see this getting cancelled, what's the final answer? My final answer is minus 2x upon what? This thing. Correct, right? Have a look, please have a look. Okay, moving on. Question number 3. So it's 13. 3 in the differentiation, but question number 13. Differentiate fx. Again, chain rule we have to apply. First for sine, then for cos, then for x square. Let's do it. Y equals to sine of cos of x square. Okay, okay. Check here. Please check here. So first I'll do for what? Y dash equals to cos. I'm doing for sine. So cos of cos x square. Yes or no? First thing is done. Now I'll do for the cos inside. Will become what? Minus sine what? X square. Yes or no? Yes. Then I'll do for x square. How much that will be? Simply 2x. My final answer, minus 2x. What is this? Sine of x square times cos of this cos x square. Please check this. So first I did for sine, I got it as cos. Whatever was the angle, same I wrote it here. Then I did for cos, I got minus sine. Whatever was the angle, x square, I wrote it here. Then I did for x square, I got it as 2x. I arranged it, I got it getting it as minus 2x sine x square cos of cos x square. This is my final answer. Simplest question ever, sir. Yes? Alright, let's move on. Differentiate fx. Okay? Sec x tan root of x with respect to x. Okay? So again, very simple question, same question. Y equals to what? Sec of tan root of x. Okay? First I'll do for sec, then I'll do for tan, then I'll do for root x. Please check here. Please check here. This simple question. Okay, I can give you to solve also. But let me solve this one particularly. Sec will become what? Sec differentiation is sec into tan. So first I'll do sec tan root x into tan root x. How many differentiations we have done? How many differentiation? Only one, sir. Sec differentiation is sec x into tan x. Okay, this whole thing is for what? X only, no? Some angle. So sec of tan x, tan root x, and then sec into tan. So first only differentiation is only for sec. Now next what we're going to do? We will do for tan root x. Okay, this will come later. Let me do first. Now next step over here. Sec of, let me call this as theta. Okay, theta. So I'll write it as sec theta tan theta. Okay, I'm writing this as theta. Okay. What will this be? Tan differentiation is what? Sec square. So sec square root x. Okay. What next? Differentiation of root x. Differentiation of root x. Root x means what? X power 1 by 2. Root means what? Power 1 by 2. Yes. Please check here. Y differentiation is sec theta tan theta sec square root x. Okay. What else? Sec. So I'll do it like this. 1 by 2 will come here. N will come in front, and x to the power 1 by 2 minus 1. Now I'll write the final answer. So I'll write this part in the front. 1 by 2 will be written here. X to the power 1 by 2 minus 1 is what? X to the power 1 by 2 minus 1. Minus 1 by 2. Minus 1 by 2 means root but in the denominator. So 1 by 2 root x. Please understand this. X to the power 1 by 2 minus 1. It means what? X to the power minus 1 by 2. 1 by 2 root means 1 by 2 power means what? Root, but there is a minus sign. So in the denominator 1 by 2 root x, and same thing here. So sec of theta is what? So write this, sec of tan root x, tan of tan root x times sec square root x. This is my final answer. Okay, my final answer. Okay, I wrote it back because theta I have assumed, no, I have to write the answer in the terms of variable they have given. That's why I've written back theta as tan root x everywhere. Okay, chali. Simple question only, but looks a little complicated, but simple problem only. Okay, prove that the function f given by mod of x minus 1 is not differentiable. Okay, so over here we'll use what? We'll use first principle of derivative. Principle of derivative. Derivative. What is that? LHD and RHD. LHD and RHD. How we write LHD and RHD? Let me write it over here for you. So LHD is called as what? Left hand derivative. Left hand derivative. How we define is limit f of a minus h minus f of a upon a minus h minus a. Please check here, gets cancelled. So I can write it as only minus h also. Okay, and what is this limit condition? H tends to 0. This is my LHD. Okay, what about my RHD? Same thing will happen. Please check here. So limit f of a plus h minus f of a upon a plus h minus a goes out. What is left here? Only h. Only h. So I can remove this. Okay. What's the limit condition? H tends to 0. H tends to 0. Okay. So we have to check at which point. Check. This is my a value. This is my a equal to 1 value. Function, have to define the function now. Please define the function. So y equals to, at x greater than 1. Check here. For all x greater than equal to 1, what will happen? It will be positive because 1 will be 0, then it will be 2. 2 minus 1 is again 1. 3 minus 1 is again 2. So all positive number. So the function will become what? X minus 1. Yes or no? X minus 1. What about all the numbers before 1? All the values before 1, what will happen? It will open with a minus sign. Check here, minus 2. So what's the answer? Minus 2 minus 1, how much is that? Minus 2 minus 1 is how much? Minus 2 minus 1 is minus 3. So mod will make it positive. Okay. So minus 2 minus 1. How much is this? Minus 3. What is the answer now? Answer is minus of minus 3. How much is that? Plus 3. Sir, can I not write simply like this? 3. Yes. But how is this becoming 3? Because modulus is opening with a minus sign. Okay. Mod of minus 3 is 3. How? When we open the modulus with a minus sign. No. Then this minus will make this minus positive and get the answer as 3. Okay. So whenever you have a negative number inside the modulus, it means that modulus is opening with negative sign to cancel the effect. Okay. So whenever I take a value less than 1, this mod will open with minus 1. So I'll get it what? Minus of x minus 1. How much is that? 1 minus x. Okay. So I can erase this minus of x minus 1 because minus will be minus x and minus will be plus 1. So it'll open with a minus sign. Okay. Simple. Let me erase this part also. Okay. Chaliye. Let me erase this part, bacha. Not relevant. Okay. Just to explain you why the mod is opening with a minus sign, nothing else. Okay. Let's move on. What is it now? We'll apply this concept using LHD and RHD. What is the differentiability? If you remember, when can I say function is differentiable? Whenever we have LHD equals to RHD. So I've given some concepts to you right now. How to break a question, how to break a function, okay? And then what is LHD and RHD? And when can I say a function is differentiable? So we can say function is differentiable when LHD and RHD are equal. So fx is differentiable. Look, we don't have to use the first principle. I can directly find the derivative over here. If you check the derivative over here, shortcut if you want. What is the answer? 1, because x is 1, minus 1 is 0. What's the derivative over here? Minus 1. Correct. Now 1 is 0, x is minus 1, because minus x is there, so minus 1. Check here. This is my RHD, right? More than 1 means RHD. RHD means what? RHD is 1. What is my LHD? LHD is minus 1. Are they equal? Check here. Before 1 means LHD minus 1. Is it equal? RHD 1. So at 1 what is it? 1. So RHD is 1. LHD is minus 1. They are not equal. Means not differentiable. Directly I can write it. But let's check with the help of first principle. Okay. So let me find the LHD first. I'll write what? Limit h tends to 0, and what is it going to be, bacha? F of 1 minus h, right? Because a is 1 in this case, minus f of 1 upon minus h. What is f of 1 minus h? I'm doing LHD, right? LHD means this function I have to use 1 minus of x. In place of this 1 minus of x, I'll put what? Check here. The function is 1 minus of x, and in place of x, what I'll put? The function is 1. I'll put here 1 minus of x, okay? Not x, h, okay? Minus, sorry, 1 minus of 1. I'll show you why. Don't worry. This might be confusing. I'll show you why. Upon simply minus h. Please check this. Okay? So what is the function value? Function value is 1 minus of x. Right or not? 1 minus of x. When x is less than 1, LHD will be applied on this function 1 minus of x. So if you replace 1 minus of x in this, if you replace x by 1 minus of h, fx is 1 minus of x, means what is f of 1 minus of h? Tell me. F of x is 1 minus of x. F of 1 minus h will be 1 minus of 1 minus h only, na? Same thing I've written there, right? Same way, if f of x is 1 minus of x, so what is f of 1? 1 minus of 1, right? Same thing I've written there. So no confusion, okay? Just to explain you, if you are not able to relate at this point, that's why, okay? Only one question I've taken on this concept, first principle. Let me complete it, okay? Very important. So this will become what? See from here, it will be 1 minus 1 will get cancelled. I'll have plus h, and this will be again 0 upon minus h. I will apply limit. Limit is applied, okay? Limit is applied. How much is that? Please check. This is simply limit. Okay, I don't have to apply the limit in this case now because there's no variable left. Check here, no variable left. Cancel. What is the answer? Minus 1. Answer is simply minus 1. So what is my left hand derivative? Minus 1. Check here, right hand derivative. Check the right hand derivative. Same way we'll do. Limit h tends to 0. F of 1 plus h minus f of 1 upon plus h. Any confusion? Please have a look. Plus h in this case. Why, sir? Because I wrote it as a plus h minus a. So a and a got cancelled, right? Okay. Remember this? Yes. Moving on. Let's write the values over here. Let's write the values. What is the value f of h? I'll write it as 1 plus h minus 0 upon what? Sorry. The function is different, no? Check the function, please. For f of 1 plus h, means for RHD, what is the function? X minus 1. What is the function? X minus 1. So I'll do what? 1 plus h minus 1. Okay. X is 1 plus h, and in this case again will be 0. 1 minus 1 is 0 only, sir. This is simply h. Goes out. Limit is there. H and h will be simply what? 1. Answer is h and h will cancel, right, by 1. So what is my RHD? So my LHD is not equal to RHD. So what is it? Not differentiable, sir. Not differentiable, sir. Okay. We cannot differentiate at x equals to 1. At where? At x equals to 1. Okay. This function is not differentiable at x equals to 1. Okay. Chali. Moving on. Question number 16. Okay. Now what is this type of function? This is whenever we can express a function in terms of x. Means if I have a function, let's say y equals to sin x, y equal to cos x, whenever this condition is there, I can call this function to be explicit function. I have this as y equal to cos x, y equals to x plus 1. All these are explicit function. What's the meaning of explicit function? Explicit function means what? Means I can explicitly put this function y in terms of x. Means the independent variable has direct relation with the dependent variable. Okay. Whereas in the question which is given here, do you have the subject as y? So in the previous example that I took right now, subject was always y. There is subject y over here. Please check. So I can move this tan x over here. Still you will have y over here, y over here. So subject is not there. Okay. This type of function is called as implicit functions. So we have questions on implicit functions also. Let's check this. Let's solve this. How this look like? Differentiate xy plus y square equals to tan of x plus y. Yes or no? Differentiate everything with what? x, because they're asking for differentiation with respect to x only. So I'll do what? Please check here. I'll use product rule over here. Over here simple, and over here nothing, no product rule or something. Over here product rule. So I'll keep x as it is, dy by dx. Next step, I'm only doing for xy. I'll keep y as it is, and for x will be 1. Correct, right? For x it is x, y is dy by dx. For y I'll keep it as y, and now x will be 1 because x power 1 is there, right? If you're confused, I can do it like this. One minus 1 is 0. Anything power 0 is what? 1 only. No problem. This will be what? 2y. Is it enough? No, sir. Why like this? Because y, so it's a chain rule, right? I have to differentiate y, no? First y square. So y square is 2y. What about y? Y is 2y by dx. So then whenever it was like this, x square, why there was no chain rule like this? There was. I'll get the answer as 2x. I'll get the answer as 2x. But I will do what? Differentiation of x also. What is the differentiation of x? 1. I just saw from here. So simply we can write it as 2x. So whenever we had t of x square by dx, we write this as 2x. But in the case of 2y, I have to differentiate y as dy by dx, because this is 1, so we don't write it always. This is always 1, so we don't write it all the time. So I hope this is clear. For this you'll have dy by dx, but this is simply 1. Okay, chaliye. Let me solve this question now. Okay, so this part is done. Dy by dx, put equal to tan x is what? Sec square x. Okay, and what is y? Again dy by dx. So we are looking to find the value of dy by dx, so bring all dy by dx terms on one side. So what I'm getting, check here, 1 term, 2 term, third term. Okay, I write here x dy by dx plus 2y dy by dx, and last one simply dy by dx. So minus will come because I'm moving on this side. Dy by dx will come over here, will become negative. What is this? Sec square x minus, how much is this? Simply y. Check here, simply y, because this is 1, no? 1 times of x power 1 minus 1 is 0. So 1 times of x power 0 is 1. So I can move this and write it as sec square x minus y. Take the dy by dx common, please. How much is this? X plus 2y minus 1 equals to what? Sec square x minus y. Okay, I'm looking to find this value. So I'll erase this from here and write it over there. Please check. I'll erase this from here. X, what was it? Please check. It was x plus 2y minus 1. And what is this value? This is my final answer. Dy by dx. Please write this as your final answer. Sec square of x minus y upon x plus 2y minus 1. Close the bracket. Simple. Okay. Implicit function, you have to keep going like this, and at the end take the common dy by dy, what they are asking, and proceed with the question. Lot of questions will be like this. Actually, in the exam they ask this kind of question. Okay. Over here, so see, they've asked how many times? 1, 2, 3, 4. Similar questions has been asked in same trend. So how will you do it? This will be 2x. This will be, so you have just 2x for this. You have to use the product rule for this. Product rule for this. For this will be simply what? 2y dy by dx. Yes or no? And this will be what? 0, because constant is always 0. This you make it as homework. Homework. This is your homework. Solve and comment below. That you got it, sir. Got it right, sir. Okay. Okay. Got it right, sir. GIR. What is it? Got it right, sir. Okay. If you want an answer, I don't have actually the answer, because I usually don't take the answer. I just try to solve it in the class only. But it should be, okay, I'll tell you something. Minus 2x upon, okay, minus 2x, I think this should be the answer. Please check. Minus 2x upon, okay, I have to use product rule. No, I cannot say directly. I have to use this from the product rule. Okay, so there will be 1y also, minus 2x minus y, okay, minus y upon simply x plus 2y, simply x plus 2y. I think this is true. Maybe, okay, maybe, not true, not sure, maybe. Okay, So this can be answer. Please check. Something like this you should get. Okay, maybe cross check it. Okay, maybe right or maybe wrong also, because I have not solved it. Okay, so but you'll get this answer for sure. I've given you the steps. This is 2x. This is, use the product rule over here for x and y. This is 2y dy by dx. This is 0. Bring the other terms on the 0 side and find the value of dy by dx. Moving on. Okay, find dy by dx. If y plus sin x, sin y equals to cos x. Okay, let me do it. What is it going to be? Dy by dx for the y. For this will be what? Cos y dy by dx. What is this? Minus sin x. Okay, I need dy by dx, so take it common. 1 plus cos y minus sin x. Yes or no? Dy by dx means what? Bring this over there. So minus sin x upon 1 plus cos y. Did I go very fast? This is the final answer, bacha. This is the final answer. Please check. Definition of y is dy by dx. Sin y is cos y dy by dx. Yes. This is what? Minus sin x. Dy by dx is 1 plus. I have taken dy by dx common here. What is left here? 1. Over here cos y is left. Minus sin x is as it is. I bring whole this bracket over here. So minus sin x upon 1 plus cos y. Minus sin x upon 1 plus cos y. Okay. Chaliye. This is my final answer. Moving on. Simple questions. Okay. What about this? What about this? Sine inverse. Now inverse trigonometric functions, differentiation. Let's do it, sir. Let's do it. If I do it like this, just give me 1 second. Okay. So I can write it as y dash equals to, first I'll do for what? Sine inverse. What is sine inverse formula? 1 upon in the root 1 minus x square. What is x here? X root x. So x root x the square, sir. X root x the square, sir. Okay. This is done. And what next? Differentiation of chain. We have to use the chain rule. X root x. Now see this. I'll write it here. X root x means what? What it means? X root x. It means x power 1 times of x power 1 by 2. Use the exponents rule. X power 1 plus 1 by 2. So x power 3 by 2. Yes. Same base I can add the exponent. 1 plus 1 by 2 is 3 by 2. Now please check here. 1 upon 1 minus x power 3 by 2 to the power 2 in the root. Correct, right? Same thing is there. 3 by 2 to the power 2 times of. I'll write like this also. X to the power 3 by 2. Yes, yes. Please check now. This will be simply what? Please check. 3 by 2 and 2 I can multiply. So 2 and 2 will get cancelled. 2 and 2 will get cancelled, not visible. Let me rewrite this part. Let me rewrite this thing. Okay. This is what? This is my 3 by 2 and this is simply 2. This is simply 2. If you multiply this, what will happen? Power rule, you have to multiply, right? So 1 minus x to the power 3. Okay. What will this be? What will this be? So I have to use what? Again, polynomial formula 3 by 2 x to the power 3 by 2 minus 1. Yes or no? 3 by 2 minus 1. How much is that? Please check. So this is simply 1 upon 1 minus x cube and 3 by 2 will be as it is. Okay. How much is this? X to the power 1 by 2. Yes or no? 3 by 2 minus 1 is how much? 2 by 2. Sorry, 1 by 2. This is 1 by 2, right? 1 by 2. Okay. Let's take final answer over here. Let's take the final answer over here, bacha. Okay. Quickly we'll do. So what is my final answer? My y dash or dy by dx is nothing but, I can write this as, I hope you know this, y dash also, right? So y dash is equals to, how much is this? 3 by 2 I can write in front. Okay. And x power 1 by 2 means what? Root x upon what? This whole thing. 1 minus x cube. 1 minus x cube. Right? This is my final answer. Visible? Visible? Yes. Moving on. Okay. Now, a very good question. A very, very good question. Okay. So, before going and solving this problem, okay, we'll try to break this brackets, this root. Okay. I hope this is visible. Yes. Okay. Chali. Let's see this. So, 1 plus sin x in the root. I have 1 plus sin x in the root I have. it will use now, it will require what? Some concept from the trigonometry side. So I hope you remember those formulas, okay? 1 plus sin x I have, okay. I can write this as, bacha, please understand this. 1 plus 2 sin x by 2 and cos x by 2. How, sir? Sin 2 theta formula. Remember this formula? Sin 2 theta equals to what? 2 sin theta cos theta. Yes or no? So there is no sin 2 theta. But for if I replace x by 2 theta, then I can write theta as x by 2. Please see here. If I replace this x by 2 theta, I can write this theta as x by 2 or not. Same thing I've done. So sin 2 theta becomes what? Sin x, and this I'll get what? 2 sin x by 2 and cos x by 2. Okay. Okay. Chaliye. Moving on. Please check now what this will transform into. I can write one more step, and I can write 1 as sin square x by 2 plus cos square x by 2 plus 2 sin x by 2 times cos x by 2. Yes or no? I am writing the identity now. 1 is what? Sin square x plus cos square x. So 1 can be written as sin square x by 2 plus cos square x plus x by 2. Now check here. A square b square 2ab. Please check. A square b square 2ab. This will become what? Root of sin x by 2 plus cos x by 2 the whole square. Whole square and this will cancel each other. Not visible? Not visible. Okay. This is whole square, no? How, sir? A square b square 2ab. So whole square. This will become what? Sin of x by 2 plus cos of x by 2. Please check. So I have transformed the first root, 1 plus sin x. Both I can use this for both numerator and denominator. Yes or no? Correct. Same way I'll do for 1 minus sin x also. Please check this. 1 minus sin x. This will become what, bacha? Tell me. This will become 1 minus 2 sin x by 2 cos x by 2. I don't have to explain this. Again, same formula I'm using here. Now I'll write this one as what? Same thing. Sin square x by 2, or let me write this ulta. Okay. Cos square x by 2 plus sin square x by 2, and this thing will remain as it is, minus 2 sin x by 2 cos x by 2. Visible? Yes, sir. Okay, now what will this become? Tell me. It will become a square b square minus 2ab. So it will become what? Cos x by 2 minus sin x by 2 the whole square. Whole square and root will cancel the effect. Will become what? Cos of x by 2 minus sin of x by 2. Yes or no? Yes, sir. Okay. Yes, sir. All right. So I get this as answer. For this one, for the plus sign, I get sin x by 2 plus cos x by 2. For this, I'll get cos x by 2 minus sin x by 2. Okay. All right. Okay. I can take ulta also, but I don't want in this particular case. That's why I've taken in this way. Okay. I can take ulta sin x by 2 also minus cos x by 2 also, but I require in this format. So cos x by 2 minus sin x by 2 equals to, and as this value. So please understand this. This value over here, this root is equal to this value, and this root plus 1 is equal to this value. Yes. Okay. Now let me just quickly go ahead and solve the problem. Okay. All right. So now let me just take the expression only. Cot inverse of. Now please check. In place of 1 plus root of 1 plus sin x, I can write what? Sin x plus 2 plus cos of x plus 2. So look at what? Sin of x by 2 plus cos of x by 2. Please check. Instead of this root, I am writing this part. Any problem? I just simplified. No, this I got it as this. So I can write this as cosine of x plus 2 plus cos of x plus 2. Sorry, x by 2. Now I can write 1 minus sin x as cos of x by 2 minus sin of x by 2. 1 minus sine root, 1 minus root of 1 minus sine x. From here, please check. Cos x by 2 minus sine x by 2. So what is the sign here? This is a plus sign. So plus sign I'll write over here. And simply cos of x by 2 minus sine of x by 2. Please close the bracket. Okay, close the bracket. Please check now. 1 plus sine x means same thing I'll write here again. 1 plus sine x for the denominator. Sine x by 2 plus cos x by 2. Sine x by 2 plus cos x by 2, and with the minus sign. Why minus, sir? There's a minus sign over here. So minus sign. Same thing I'll write here. So cos x, sine x. So minus okay, now please check this step. Okay, so sine and sine will get cancelled. Okay, now cos with this will get cancelled because minus will make it negative, and this will become what? Simply please check. Cot inverse of 2 cos x by 2 numerator. Cos x plus cos x is cos x by 2, and what is going to be sine x by 2 plus sine x by 2. Minus and minus will become what? Plus. So 2 sine x by 2. Cancel this 2 and 2. What I get? Cot inverse of cot x by 2. Why, sir? Cos by sine is cot. Cot inverse of cot is what? Simply x by 2. This is my final answer. This is my final answer, sir. X by 2 is my final answer. Please check. Have a look. Okay, have a look. Moving on. Okay, chaliye. 21st question. 21st question. Okay. Again, a very good problem. Let's solve it. Okay. So if I solve it like this, why am I'm supposed to find what? Dy by dx. So sine inverse of x and sine inverse of 1 minus x square. Okay. What I'm going to do? Y equals to, okay. So y dash equals to what? Sine inverse. Acha, one more thing. I didn't apply this condition 0 to pi by 2 because automatically applied. Okay. Because that is what? In that domain only, I can write this as x by 2. Cot inverse will operate in that domain only. Okay. So that has to be the case. Same way over here also. 0 to 1. Okay. So y equals to, y dash will be what? 1 upon sine inverse of x differentiation. What is it? 1 upon root of 1 minus x square. Yes or no? Yes. What about this? Plus sign. So plus sign I'll keep as it is. Differentiate this. So 1 upon root of 1 minus what? Square of this thing. So will become what? Like this, square of the root. So will become what? Same thing again. And what? Next thing is differentiation of what? This root. Yes or no? First I take this sine inverse of 1 minus x square like this, and then I have to differentiate this also by chain rule. Okay. Now please check. Okay. I'll require a little more space. Okay, I'll require more space, so I'm going to start from here. Next. So my y dash will look like what? 1 upon 1 minus x square, and this will be what, bacha? Tell me. 1 upon simply 1 minus, what is it? Square and root will cancel the effect. So 1 minus 1 and plus x square. Yes, this thing is under root, right? So this and this will go out. Okay. Now what? Product is rule is there, right? So chain rule is there. So what will I write here? What is the root here? Root is of 1 minus x square. So I can write this as what? 1 by 2. Root is nothing but 1 by 2. So simply I can write this as differentiation of 1 minus x square, right? Please check. Please check. 1 minus x square, the power 1 by 2. Next step you check here. So 1 upon 1 minus x square plus, what is this? Root of x square, because 1 and 1 is gone. So root of x square is simply x. Simply x. Now please check here. What I'll get here? So 1 by 2 root of, let me write it again just in case. 1 by 2, what I'll get here? 1 minus x square, 1 by 2 minus 1. Okay. Then I have to do what? Differentiation of x square also. So what will that be? Minus 2x. Please understand this. Minus x square differentiation I have to do. For 1 it is 0, for minus x square it is minus 2x. Okay. So this 2 and this 2 will be cancelled. This and x will be cancelled. What I have left now? Please check. 1 minus x square. Now this minus sign, this plus will make minus. Please say minus sign and this plus will make minus. Now 1 minus x square the power 1 by 2 minus 1 is how much? Minus 1 by 2. Minus 1 by 2 means root but in the denominator. So same thing with the same root. Root power is what? 1 by 2 minus 1. So minus 1 by 2. Root means minus 1 by 2 means root with the denominator. So but in the denominator. So same thing is there. Answer is 0. Please check. Answer is 0, sir. Yes? Okay. Simple problem. Alright. This is good. This is very good question. Let's see here. So I have to apply sine inverse first of all. To differentiate this just for sine inverse will be very complicated. Don't you agree? Because sine inverse of this 1 upon root of 1 minus this square will become very, very complicated. It means this has to be simplified somehow. How will we simplify this? By using some identity. Why is that, sir? Because sine inverse will not operate on this directly. So let's check. I can rewrite this bracket. I'm writing this bracket again. I can rewrite this bracket as 2 power x plus 1 upon 1 plus 4x, 4 power x as what? 2 power x times of 2. Correct, na? Right? 2 power x plus 1 means 2 power x times of 2. And I write this as 1 plus 2 power x the square. Yes or no? 2 power x square is going to be 2 power 2 only. Check here. 4x is there. So 2 power x. Okay. I can bring this x inside 2 up. So 2 power, I'm writing just for this part. Okay. This will become what? 2 power x. So 2 times of 2 power x upon 1 plus 2 power x the whole square. Is it forming a pattern? If you remember, just take this. 2 power x as tan theta. Tan theta. Okay. 2 power x as tan theta. So what will this become? This will become 2 tan theta upon 1 plus tan square theta or not? Please check. I have taken 2 power x as tan theta. So 2 tan theta upon 1 plus tan square theta. What is this going to be? Simply sine 2 theta if you remember. This is the formula of sine 2 theta, right? 2 tan theta upon 1 plus tan square theta, sine 2 theta. Now put it in the given function. Sine inverse of this thing will become what? Simply sine 2 theta. How it has become sine 2 theta? By using this approach and this substitution. This substitution, it is this side. What is this answer now? Please check here. Simply 2 theta. Sine inverse of sine is 2 theta. Sine inverse of sine is 2 theta. Yes, okay. What's theta value from here? Please check. I have taken 2 power x equals to tan theta. It means what? It means theta is equals to tan inverse of 2 power x or not? Yes. So what I got the function of y as? 2 theta means 2 times of tan inverse of 2 power x or not? Please check. I got y as 2 theta. It means theta value is what? Tan inverse of 2 power x. Okay. Now I got the same thing in the terms of x. I can differentiate now. So my y dash will be equal to 2 will be as it is. What is tan inverse differentiation? 1 up plus 2 power x the whole square. Right? Whatever in the bracket, take the square and then differentiate this also. Differentiation of exponential function like this. I get what? 2 upon 1 plus 2 power x square is what? 4 power x. What is it going to be? 2 power x ln a. Correct? A power x differentiation is ax ln a. Okay. What is it going to be? Check here. 2 times of 2 power x. Simply 2 times of x plus 1. 2 times of 2 power x. So 2 times of x, this is 1, right? So x plus 1 ln a is what? Sorry, this is 2, okay? In this case, a is known, no? It's not a variable. Okay, excuse me. It's ln 2, okay? Divided by 1 plus 4 power x. It's my y dash. Please see this, okay? I'll repeat this step. Previous one you understood, right? So what is this? This I took the bracket here and I got the expansion of 2 power x plus 1 as 2 power x times of 2. Same thing I did with power rule over here in the denominator. Okay. Now what I got? 2 times of 2 power x plus 1 plus 2 power x power the whole square. I got the substitution 2 power x equals to tan theta. After substitution what happens? It becomes the formula 2 tan theta upon 1 plus tan square theta. That's the formula for sine 2 theta. Right? Identity. I use sine 2 theta. I got sine inverse of sine 2 theta as 2 theta. My function is changed now y to y equals to 2 theta. What's the theta value? 2x is assumed as tan theta. It means tan inverse of x 2x will be theta. Substituted this for theta, I got this expression 2 tan inverse of 2x. Okay, now I had to find derivative. Okay, derivative means I had to take 2 common and differentiation of tan inverse. The same thing is here, but chain rule will also apply to 2 power x. The differentiation of a power x is what? A power x ln a. Okay, so that's why ln a is what? 2 in this case, so ln 2. Answer is 2 power x plus 1 ln 2 upon 1 plus 4 power x. Okay, moving on. Alright, I hope in this question you know this formula, right? Log of a to the base b can be written as log a by log b, right? I can write it like this, log of a power a to the base b as log a by log b. Same formula I'll use here, please check. So I can write this y as log of 7 is there, right? So log of this thing, right? So log of x. Please understand this. If it is not clear, if it is not clear, let me rewrite this. I can rewrite this as log of 7 with base, let's say y. I'm writing this log x as not y. Let me write it as okay, maybe some other variable. Y is a function, right? So maybe let's take it as p. So log p, I'm taking log x. This log x is p. So what I can write simply as log p upon log 7 or not? Yes or no? Yes, same way, that's what I'm saying here. So log of p means what? Log of log x. So log of, please check here, log of log x upon what? Log of 7. Log of 7. Yes, okay. Log of log x upon log of 7. Yes, sir. Okay, great. I've used the same formula. Okay. Now I have to differentiate it. How will I differentiate, bacha? Y dash. So log of 7 will come out. It's a constant. Okay. Log of 7 is a constant. Please understand this. Now what about this? Log of log x means what? 1 upon log x first, right? Differentiating this first, log this. So 1 upon log x. Now to differentiate what? Log x will be what? Again 1 upon x. Chain rule I'm doing. Please understand this. Log 7 is a constant taken out. Okay. Now log I'm differentiating the first log. So log is operating on the log x, so that will come in denominator. Now I'm doing for what? Log x will become again 1 by x. What is my answer? My answer is 1 by log 7 x log x. X log x. Yes, simple bacha. Okay, moving on. Chaliye. Now, acha, one more thing. This is a concept, please remember. Whenever you have the function given in terms of power, okay, or product or quotient, what do? Simply apply log on both sides. Simply apply log on both sides. Okay, and then what you're going to do? Then you can do the derivative part. First you do what? If the power, check here, if the power is present in the function, if there is a product present in the function, product of two functions, or quotient is present. For all this situation, what you have to do? Find, apply log on both sides, and then find the derivative. So we will check here. Please check here. Okay, I have enough space. So let me write this as y equals to root of x minus 3. So I can write root like this, no? I hope you remember. Yes, you know, I know you know. I used in the previous question also, x minus 3 times of x square plus 4 divided by 3x square plus 4x plus 5 with the power what? 1 by 2. Root means what? Power is 1 by 2. Now what did I say? Power is there. So take log. So log of y will become what? Log of this thing, whole thing, x minus 3 x square plus 4 upon 3x square plus 4x plus 5 with the power 1 by 2. Yes or no? With the power 1 by 2. Now this 1 by 2 will be taken over here because log with the power becomes what? Power comes as coefficient. So what will this be? 1 by 2 log of the same bracket. Hope I'm not making any mistakes. Please check if I missed some plus sign or minus sign somewhere. Sometimes it happens in continuity. So please check 1 by 2 log of x minus 3 x square plus 4 3x square plus 4x plus 5. Okay. Now we'll take the differentiation. Can we take the differentiation now, sir? Actually, we can do one more step. Log applicates. Look at here. Log, what is this now? First was product. Sorry, first was power. Now what is this now? Quotient is there, right? Log of this bracket by this bracket. Right now, log of operating on the numerator by denominator. I can write this as, please check. Log y equals to what? 1 by 2 is outside. Log of, please check, x minus 3 x square plus 4. Okay, minus sign. Okay, we know that log of a by b is log a minus log b. So I'll do minus log of 3x square plus 4x plus 5 minus log of 3x square plus 4x plus 5. Okay. Okay, correct na? So I have applied what? First applied power rule, power formula for the log, then I applied quotient. Okay, log a by log b, log a by log b. Now you see, I also have product here, so I can apply this again. See, I have taken a question where everything is there. Okay, so 1 by 2, apply the product here. So log of x minus 3 plus log of x square plus 4. Okay, and this will remain as it is. So log of 3x square plus 4x plus 5. Okay, have I missed anything? No, sir. Now we'll take the differentiation. What is the differentiation of this? It will become 1 by y dy by dx. Yes or no? Please check. Log y will be 1 by y, and then y have to do again chain rule, dy by dx. Keep 1 by 2 as it is. Keep 1 by 2 as it is, and take differentiation inside. What is the differentiation of this? 1 upon x minus 3. For x it is 1 and 1, so I don't have to change anything. Okay. What about this? 1 upon x square plus 4. I have to differentiate this also, so will come as 2x. Will come as 2x. Please check. For x square will be 2x. This is x square. Okay. And for 4 it will be 0. So simply 2x. What about this? 1 upon 3x square plus 4x plus 5. And for this I will get what? 6x here and plus 4 there. 6x here plus 4 there. Okay, so I want to find what? Value of dy by dx. So bring the y on the side. I'll get what? Y by 2. Y by 2. What is this thing? 1 upon x minus 3. What is this? 2x upon x square plus 4. What is this? Minus 6x plus 4 upon 3x square plus 4x plus 5. Okay, this is my final answer. So y, I can write this y. No, again, this whole bracket can be written over here again. So just write in the final answer, just rewrite this y as this bracket. Okay, this whole bracket, again rewrite it over here. This is my final answer, bacha. Understood, guys? Okay, I hope. Okay, I know the session is getting lengthier. Okay, we are still completed how many questions? 24 questions we have completed, but that's a good amount, right? We have dealt with continuity. We are solving variety of questions in differentiation. It'll take time, bacha. The session will be longer. I wanted to complete this chapter in one shot, not take a break, because I don't know at which stage you are right now. Okay, I don't know what you need to revise. So I've taken everything in one session, compiled it, taken variety of questions, solved all of them in one session, so that whatever you require, your requirement should be fulfilled from the one video only. Okay, so I'm gonna complete all the problems right now. Maintain the energy. If you need to take a break, okay, I hope you're able to understand the solutions. Okay, for all the questions I'm writing the concepts whenever it's required. Okay, formulas I also revise for you. Concepts of continuity also explain a little bit. Differentiability also explain a little bit. Okay, so whatever is important, I'll give it from my side. If you need to take a break, take a break, have some water, then again come back in 2-3 minutes and continue with the session. So let me proceed. Again. What is there here? Again, power is there. So I will use what? Very simple. Y equals to x sin x is given function. Okay, not x sin x power sin x is given function. Okay, give me x power sin x is the given function. Okay, bacha. Differentiate with respect to x means what? Simply dy by dx they're asking. So y dash, excuse me. Okay, before that, my statement I forgot. Apply log on both sides. If I apply log, what will happen? Sin x will come in front. Correct, na? They'll come in front. Okay, now what I have? So I have log y. Please check. I have log y equals to sin x log x. Okay. What I'm going to use? This is log x. I hope this is not. It's looking something different. Okay. Not looking as log x. So log of x sin x times log of x. So I'll differentiate this. Differentiate this with you. What? Product rule will become what? 1 upon y dy by dx. What will this be? Sin x will be as it is. Sin x upon 1 by x. Then what I'm going to do? Sin x will be cos x log x. What is the final answer? Bring the y over that side. So dy by dx will be what, bacha? Tell me. Y times of, what is my y? X sin x. So let me write that. Okay. Let me write that. Y times of what? I'm taking this y over here, right? So it will be what? X sin x. X power sin x times what? Sin x upon x plus cos x log x. This is my final answer. This is my final answer. I hope this is clear. Yes? Clear? Okay. Very, very simple problem. Okay. Expect it for 2-3 marks. If it comes, 2-3 marks is more than enough for this question. Again, same thing. Power is there. Even for log, we have to apply log again. So check this. I will not solve this question. I'll give you a hint. You have to solve from your side. Y equal to log of x to the power cos x. So do one thing. Apply log. Log y equals to, what will happen? Log of log x to the power cos x. This will come in front, sir, as a coefficient. So log of y equals to cos x log of log x. Okay. What you have to do? Find differentiation. So find the differentiation over here. Okay. Solve this. This is your homework. That's to practice. Okay. This is to practice. How are you going to solve this? Cos x will become what? Minus sin x. So you have to use what? First of all, you have to use the product rule. So for cos x, you'll do, keep this as it is. Next, what are you going to do? Keep cos x as it is and do it for this. Then when you're doing for this part, you have to use chain rule also. First, what you'll do for log. So 1 by log x will come in down, and you have to do for log x also. So again 1 by x will come in down. Okay. So first you have to use the product rule. Okay. And for this part you have to use what? Chain rule. Okay. Chaliye. Moving on. Sin inverse of x to the power x. Same way. Exact same way. Nothing different. Y equals to sin inverse of x to the power x. Take log on both sides. Log of y equals to x log of, I'm writing it again now very fast because this x will come in front of the log. Okay, so x log of sin inverse of x. Okay, derivative if you want to take 1 by y, what is it? What's the derivative? Derivative is 1 by y d by dx equals to, keep x as it is. So yes, keep x as it is. So x as it is, what will this be? 1 upon sin inverse of x for the log, and for sin inverse what will have? 1 upon 1 minus x square. Okay, and what about this? Next time I'll keep I'll do what? Plus sign. X will be 1 and this whole thing will be kept as it is. So what will that be? Tell me. Log of sin inverse of x. What is my final answer? Please check. My final answer is, I'll write it here only, dy by dx equals to y multiplied with x upon 1 minus x square in the root times of what? Sin inverse of x, and this is simply what? Plus log of sin inverse of x. Log of sin inverse of x. Yes. Okay. Log of sin inverse of x. Correct, right? Log of sin inverse of x. So because I have kept this, first I kept x as it is and differentiated this part. So I have to use chain rule. Next I have to just keep this as it is, log of sin inverse of x, and for x it is 1. So log sin inverse of x is as it is. This is my log okay, log of sine inverse of x, okay. So this is my final answer. Put for y value from here only, okay. Sine inverse of x to the power x will come in place of y. So solve it if you want. If you're not getting it, my solution, solve from the homework side, okay. Keep it as homework. Simple question, right? Apply log on both sides and do the differentiation using product rule and chain rule, okay. Over here. Now this is a very good question, okay. I said, sir, you said that apply log whenever you see power, okay. Whenever you see power or product. But check here, bacha, there's a plus sign in between. So log of a plus b is what? If I'm writing here, log of a plus b, sir, it is equal to log of a plus log of b. Wrong. Wrong, right? Log of a into b is log of a plus log of b, okay. No mistakes over here, no mistakes over here. Log of a plus b, you cannot have any standard formula for that. So what you're going to do, take this to be a different function. Let's say I'm going to take this as a function s and this as a function t, s and t, okay. Now you'll check here, okay. So I'll take this as s equals to log of x to the power x, okay, log of x to the power x, okay. Now differentiate again, now you take the log, it will become what? Log of s equals to log of x to the power x. Now this x will come in front, okay, this x will come in front. So this will become what? Log of the letter s, x log x, x log x, okay. Now I'll take the differentiation, it will become what? 1 upon s ds by dt, ds by not dt, sorry, ds by dx, right? ds by dx. Used to that expression, that's why I wrote it like this, ds by dx, okay. So this is the function right now given. I'll show you later. Right now, I have to use what? First product, then chain rule. So do for I'll keep x as it is. What will this be? 1 upon log x. For first log, 1 upon log x, and for this log, it will be what? Chain rule, 1 upon x. Please see here. So x and x will cancel. Now plus sign. I'll do for x, how much that will be? Simply 1, and this will remain as it is. So log of x. Now please check. I'll simplify and tell you here. So my 1 upon s ds by dx will look like this. Please check. I have 1 by log x left here. So 1 by log of x. What is this? Plus this thing. Log of x. Right now, this is a plus sign here. Okay. Log of x. This x is cancelled with this x. Okay. No problem. So I want the ds by dx. So my ds by dx is going to be what, bacha? Multiply s over here. So s times of 1 upon log x plus log of x. Log of x. Yes or no? This is my first one. Same thing I'll do for the t also. Same thing I'll do for t also. So let me just put the value of x back here. So I'll get here my final answer. For the first part, I get here ds by dx equals to, what is s value? Log of x to the power x multiplied with 1 upon log of x plus log of x. Too many logs. What can I do? That's how the question is. Okay. So log of x to the power x, this expression is there. This is only for differentiation of first part. Next is what? X to the power log of x. Next is what? So which is what taken as t equals to x to the power log of x. What I'm going to do, tell me. Differentiate it over here, please. If I differentiate over here, what I'm going to get? Dt, sorry, first I have to take the log. First I have to take the log, sir. So it will become what, bacha? Tell me. T equals to, forgive me, I have to take log t, right? I'm taking log t. It will become log t equals to, apply log on this side. So log of x to the power log x. Okay. What will this be? Tell me. So log x will come in front. So it will be log x. This is coming in front. Okay. Times of log of what is left here? Just x. Okay. differentiate please, what is this, please check, log of x to the power 2, log of x power 2, okay. Alright, so great, log of t, now differentiate this, what are you going to get, 1 by t dt by dx, okay, dt by dx, okay, what will this be bacha, 2 log x times of 1 by x, yes or no. First for log x power square, which is going to be 2 log x, then 1 upon x for log x. What is my dt by dx, tell me here, t multiplied with 2 log x upon x, yes or no, yes sir, okay. So put the t value back, I get what, dt by dx equals to, t value is what, x power log x times of, so 2 is there, right, so I can keep the 2 here, log of x whole thing divided by x. This is my second value. They were asking what, for the given function given like s plus t, they were asking what, dy by dx, then dy by dx will be what bacha, ds by dx plus dt by dx. So I took the question to be y equals to s plus t. So they are asking us differentiation means dy by dx equals to ds by dx upon dt by dx. Both expressions are there, just add it, okay. My final answer will be dy by dx equals to, please check here, first one, log of x to the power x, log of x to the power x, the bracket 1 upon log x, log of log x plus log of log x. What is this, tell me, what is this? This is my first part, ds by dx, okay. Now plus sign, this part dt by dx, what is that, 2 times of x log x times of log x upon x. My final answer. Looks complicated, but yes, if this question comes, they have not asked it, okay, they have asked it, okay. If this question comes, pakka 5 marks, okay, once they have asked, okay. This is not a midterm paper, but if this kind of question is coming for your paper, but first have a look, okay, okay. If this question is coming, it will be a higher weightage question, okay. I have taken this question into 2 parts, s as first part, t as the second part. I differentiated s as and got this my result as ds by dx, okay. Same thing I differentiated t also, got this also for dt by dx, put it together for dy by dx equals to ds by dx plus dt by dx. This is my x bacha, this is my x, okay, simple. Alright, so visible, right, everything is visible, okay. Moving on, same condition, we have to apply what, again take this as s and this as t, correct, and take the differentiation individually. So this is your homework, exact same steps. I'll give you a little bit hint. So if you take s equals to sine of x to the power x, tell me what is going to be the log. So log of s will be what bacha, x log sine x, okay. Same way, what will this be, if you take I don't have to take the sine inverse, I don't have to take this log over here, simply t equals to what I'm going to taking, sine inverse of x, okay, sine inverse of root x. So I'll get what, dt by dx equals to what, 1 upon 1 plus root x, sorry, minus is there, okay, minus root x the, okay, let me write this again. So 1 minus root x the whole square in the root, okay, and times of what, differentiation of root x, okay. So you have to use the chain rule over here. For this again you have to use product and chain rule together. So when you do that, you'll get the answer, put them together. This is a simple question, this is not as difficult as the previous one, okay. So see, this will become what, 1 and keep this log sin x as it is, next we'll keep x as it is and keep this as 1 by sin x times of cos x, okay. So you'll get this answer, okay. Solve this, and then club them together to get the final answer, okay. Solve it, okay. Comment that question number 29. Got it sir. Okay, got it sir. Okay, चलिए आगे बढ़ते हैं. 30th question, 30th problem. What is it sir? Differentiate x to the power x cos x plus x square plus 1 upon x square minus 1. Again same approach. Let me do it anyway. So let me do it. Previous question I gave you homework. This one I will solve. Okay. One simple one was previous one was simple one, so I gave it to you anyway. So let me take this as again. I'll take it as p. Okay, and this is q. Take this function as p and q. Okay. Again every time s and t makes things confusing. So let's take it as p and q. So I'll differentiate p first and then we'll go to q. How will I do the differentiation of p? Not y, used to taking y. So take this as p. P equals to x to the power x cos x is there, bacha? Yes, yes. Take what? Take the log now. Take the log. So what I'm going to get? Log of x to the power x cos x, right? X to the power x cos x. So x cos x will come in front. I'll get what? X cos x log x. Yes or no? This is what my simply log p. Differentiate it. It's not log p. It's log p. Okay. Okay. Log of p. Differentiate it. I'll get what? 1 by p. What? dp by dx. What on this side? I'll keep. I have to do for 3 steps now. X log x. See, check here. X cos x log x. 3 functions. So let's do for x first. So I'll do for. Let's do what? Let's keep this as it is. Do for log x. So I'll do x cos x as it is. For log x, what is the function? What's the derivative? 1 by x. Okay. Now I'm going to keep x log x as it is. Please check. X log x as it is. And for cos I will do. For what is for cos? Minus sine. Yes. And then I'm going to do what? Keep cos x log x as it is. So cos x and log x as it is. For x, what is it? Simply 1. Okay. For x, what is it? Simply 1. Please check. What is my answer now? So I'm getting this as 1 by p equals to, 1 by p dp by dx equals to, dp by dx equals to, what is it? First line you see? Cos x, simply cos x, because x and x is cancelled. So cos x plus sine, okay, there's a minus sign here, minus sine x. So minus sine x minus x sine x and log x is also there. Okay. What is the last step? Simply plus cos x log x. Plus cos x log x. Okay. I want to dp by dx value. Put it here. dp by dx will be what, bacha? Multiply p on the other side. What is p? This value. So x power x cos x, not s. Please check. Have a little bit patient. X cos x multiplied with what? This whole bracket. Same thing. So cos x minus x sine x log x plus cos x log x. First part is done. Yes or no? First part is done, right? Second part is q. X square plus 1 upon x square minus 1. Please check here for q. Q is x square plus 1 upon x square minus 1. Am I right? Yes, sir. Differentiate it, please. So I don't have to take the log here. Just take the differentiation. dq by dx. Why, sir? I can use the quotient rule, no, of the differentiation. So I'll keep this. I'll do it for this first. So I'll keep x square minus 1 as it is. For this I'll get what? 2x. Correct, na? For this I'll keep as it is x square minus 1. For this I'll get 2x. Now minus sign will come. What is it going to be? I'll keep x square plus 1 as it is. I'll get this as x square minus 1 will again be 2x only. Divided by denominator the whole square. Denominator the whole square. Right? Please check the differentiation now. So my dq by dx will come as, what will this be? 2x cube, please check. 2x cube minus 2x. Yes or no? 2x into x square is 2x cube. 2x into minus is minus 2x. Okay. Again 2x with x square will be what, bacha? Plus 2x cube. Okay. But there's a minus sign over here. So it will become what? Minus. There's a minus sign over here, right? Not over here. There's a minus sign over here. So it will be what, bacha? This is to minus only. This is also minus. Okay. What about this? 2x, positive 2x with minus sign. So negative 2x. Negative 2x. Okay. Divided by the whole square. X square minus 1 the whole square. Please check. This and this is getting cancelled. What is my final answer for dq by dx? my dq by dx is coming as minus 4x upon, please check, minus 4x, minus 2x, minus 2x is minus 4x upon this thing, x square minus 1 the whole square. What were they asking? dy by dx was nothing but dp by dx plus dq by dx. What's my dp by dx? Please check here. X cos x, x to the power x cos x multiplied with what? Cos x minus x sin x log x, cos x minus x sin x log x, okay. One more term is there, plus cos x log x plus cos x log x, and this is for the only this part. For this part I have to write what? This term. So minus 4x upon x square minus 1 the whole square. So this is my final answer. This statement minus this statement. This is together, okay. This whole thing is together. Okay, minus sign is there. There's a minus sign over here. Okay, simple, not simple, not simple, but simpler than the previous question. Okay, then the 28th question is simpler. Okay, so first you take this differentiation with the help of log, and this you can take simply by quotient rule. You'll get the different expressions. The thing is, it might be lengthier, but not difficult actually. See, approach is very same, right? Looks very lengthy because of the question's strength. Again, this is coming. Will be 5 marker, not asked but 5 marker. Okay, big question. Check here. So approach is same. The quotient rule, the product rule is applied for 3 terms. So first I kept x cos x as it is. I did for log x. Quotient rule, product rule, right? I keep the 2 terms as it is. I did for the 3rd term. Next I did what? I kept for x log x as it is. I did for cos x, and then I did for x and kept other 2 as it is. Okay, simplified it and get the answer. There will be 3 terms over here. This is my p value, cross multiplied from here, p x power x cos x, x power x cos x. Moving on, question number 31. Now so far we were dealing with what? Whenever the sum of 2 different functions are given, how to differentiate it. So we'll differentiate it individually and give the result. Now we have parametric form. What is there? Parametric form. Okay, let me recall some of the parametric form. What was there? What was the concept of parametric form? So something is called as parametric form. So we have 2 things left now. We have 2 things left in this, parametric form and second derivative left now in this function. Okay, so parametric form will look like what, bacha? Tell me. So if I have a function y, okay, written in terms of t, I have another function x written in terms of t again. So dy by dx can be rewritten as dy by dt upon dx by dt. Please understand this. Okay, please understand this. If I have a function y in terms of t, I have another function x in terms of t, then dy by dx can be written as dy by dt upon dx by dt. Okay, dy by dt upon dx by dt. Okay, simple. Chaliye. So means I can differentiate the first function, second function, and take the ratio. Same way, please check here. I have x as it is and y as this. But what is the variable here? Is theta, sir. Variable is theta. So I'll differentiate both y and x with respect to theta first, and then take the ratio to get my dy by dx. Understood? Please understand. I'll repeat my statement. I have y and x given in terms of theta. Okay, theta. So I have to find dy by dx. So what I'm going to do, I'll find from here dy by d theta, from here dx by d theta. Using these 2, I'll take the ratio and get dy by dx, parametric form. Okay, chaliye. First one, let's do for dy by d theta. So a is a constant, I can keep as it is. What is this going to be? Sin theta will be simply what, bacha? Cos theta. Theta is a constant again. Theta is a variable, right? Theta is a variable, not a constant. A is a constant, theta is a variable. I have to use the product rule here, so minus sign. Theta will be what? 1. Cos theta will be as it is. Okay, see here, I am using product rule now. So theta will be kept, for theta differentiation is 1. For cos will be, cos I'll keep as it is. Next what I'm going to do, plus sign, I'll keep theta as it is. And for cos what I'm going to get? Minus sin theta. Please understand this. A is a constant kept as it is. Sin theta differentiation is cos theta. Now I have to use theta into cos theta means product rule I have to use. Theta will be 1, cos is kept as it is. Now theta is kept as it is and cos is minus sin. Okay, let's see the expansion over here. Cos theta minus, this will become simply minus cos theta, and this will be minus theta, sin is there negative, will become plus theta sin theta. Okay bacha, please check now. Gone, what I get? A theta sin theta. What is this? Dy by d theta. Yes or no? Same I'll do for dx by d theta also. Can I do it over here only? Let me do it in the next slide. X is given as what? X is given as a times of, let me check here please, cos theta plus theta sin theta. Cos theta plus theta sin theta. Am I right? A cos theta plus theta sin theta for x. Yes, let me simplify it again. What I'm going to do, parametric form, so dx by d theta. Okay, keep a as it is. For cos I'll get what bacha? Minus sin theta. Okay, for here I have to use what? Product rule again. So I'll use a bracket again. Theta will be 1, sin theta will be as it is. Okay, and next what I'm going to do, I'm going to keep what? Theta as it is and sin will be cos theta. Please check. This is multiplication, okay? Multiplication. So what I'm going to get? A times of minus sin theta plus sin theta, opening bracket, and plus theta cos theta. Yes or no? Please check. What I'm getting? A theta cos theta as my dx by d theta. What they have asked us to find? dy by dx. dy by dx. How much is dy? dy was a theta sin theta, if you remember, and this is what? A theta cos theta. Goes out. How much is that? Sin by cos, which is tan theta. Please check here. A theta sin theta is my dy by d theta, and this is a theta cos theta, and divided them to get the ratio as tan theta. Answer is tan theta. Okay, what is the answer? Tan theta. Okay, so dy by dx is nothing but tan theta. This is your final answer. Okay, simple. Parametric form means you will do the differentiation with respect to the variable or the parameter given. In this case, what is the parameter? Theta was the parameter. With the parameter which is given, do the differentiation with respect to that and then take the ratio of the two differentiations. Okay, chaliye, moving on. Question number 32. Okay, same approach. What you have to do here? You have to find what? Dx by dt and dy by dt. I'll give this as homework. Okay, same approach. Okay, homework. dy by dt, what will be this bacha? Same check here. Dy by dt again get, and then what I'm going to do? Dy by dx will be what? Dy by dt upon dx by dt. Yes or no? So far I think I've given 3 questions as homework. This is my 4th problem. 4th question I've given as homework. Okay, solve it and get me the answer. Comment in the comment section. Okay, but make sure that you're writing the question number. Then only I can cross check. Okay, then only I can cross check dy by dt and dx by dt. So if you solve it, what are you gonna do? Please tell me. I'll give you a hint for dx by dt first. So let's check here. What I'm gonna do? So I have to use what here, bacha? I have to use what? I have to use the product rule first. Sorry, quotient rule first. So let me just solve one part for you. So let's say I'm going to do sine cube first. So it'll be what? 3 sine square t, yes, times of what? Cos t, yes, and this will remain as it is, root of cos 2t, yes or no? Now next comes for minus sine. Okay, now I'll keep sine cube as it is. Okay, and differentiate what? This part, cos 2t will become what? 1 by 2 cos 2t to power minus 1 by 2. Yes, because 1 by 2 minus 1 will be minus 1 by 2, and times what? Minus sine 2t times 2. Yes or no? Please check. Okay, so if I'm simplifying this, please check here. 1 by 2 and this 2 will cancel each other. Okay, and denominator is there. there's a quotient rule, right? So denominator will be there. What is this denominator? Square of this term. So simply cos 2t. Square of root will be, square and root will cancel, so cos 2t. Okay. So what is now, if something is common, please check. Sin square t is common from here. So I'll take sin square t common. Sin square t is common. Okay. 2 and 2 is already cancelled. I can take, this is in denominator, right? Please check here. This is power what? Minus 1 by 2 means denominator. Okay. So I can write this as, what is left now? Please check here. I have this as cos t times of cos 2t in the root, first term. Now this one minus and this minus will become plus. Okay. This minus here and this minus will become plus. Okay. This sin square I have taken, so what is left here? Sin t is left. So plus sin t. Okay. This is in denominator, negative sign. So what is going to be this? I'll multiply the numerator first. So sin 2t. Okay. And this will be what? Cos 2t in the root in denominator. Okay. Again divided the whole thing by cos 2t. This part will be there. Okay. This part will be there, bacha. Okay. I can erase this over here. Okay. Okay. 1 second. Give me 1 second. I'll write just, let me make some space. Let me make some space. And I can write it like this, right? This whole thing divided by what, bacha? This whole thing is divided by cos 2t. Okay. Same goes over here also. This whole thing is divided by cos 2t. Okay. Next is simplification. You will take the LCM of cos root 2t. Root of cos 2t will become what? Cos 2t, because root is here. So multiply, you will get cos 2t, and this cos root 2t will come in denominator. Okay. So simplify this. You will get an answer. It will be calculative, but you will get an answer and find this answer. So once you get the answer, give me your final answer. It will be difficult to write in the comment section, but try. Okay, if you want, you can put a snap of this also. Okay. So please solve this homework question. What are we going to do? Again, I'll write the final step. So you write it as dy by dx will be equal to what? Dy by dt upon dx by dt. Dx by dt. Same approach you use. I have tried to find dx by dt, but it's very close to the answer. So the answer will come as sin square t cos 2t. I'll give you the final answer. Please listen to me. Sin square t cos 2t plus sin t sin 2t upon cos 2 to the power 3 by 2. Okay. How? Because this is 1 by 2, no? Will go in denominator, will become 1 plus 1 by 2, so 3 by 2. My final answer, if you want, I can give it to you here. I can give this to you here. Dx by dt will be what? Your sin square. So sin square t, okay? Cos t cos 2t, cos t cos 2t plus sin t sin 2t, sin t sin 2t, okay? What? Upon cos root t is there, right? So it will come here. So it will become what? Cos of 2t to the power 3 by 2. This is it, okay? This is it. So please solve the same way for dy by dt and get the ratio. Things will get cancelled. You'll have an answer. Chaliye. Moving on. Again the parametric form only. X is given in terms of t, y is also given in terms of t. So quickly let's find it. Y is so simple. Let's find for x only first. So if I find for x first, okay. So what I'm going to do, dx by dt will look like what, bacha? A will be as it is. Cos t will be what? Minus sin t, okay. And this will be what, bacha? Plus log of this 1 upon tan t by 2, correct, na? Tan t by 2, okay. And then what? Log of log is done, differentiation. Now do for tan secant square t by 2. I have to do for t by 2 also. How much is that going to be? Simply 1 by 2. Correct. First I did for log, so tan t by 2 in the denominator. Then I did for tan t by 2, so got sec square. For t by 2 I get 1 by 2. Okay. Please simplify this. Minus sin t plus. I can bring the sec in the denominator only. So 2 is also denominator, so I can write 2 tan t by 2, and this will become what? Sec square will come in denominator, will become what? Cos square. Cos square t by 2. Okay. Please check now. Okay. I have space. Chaliye. Minus sin t plus, what will this be, bacha? Please check here. 1 upon 2 sin t by 2 upon cos t by 2 into cos square t by 2. Anything getting cancelled? Anything that you can see getting cancelled? Extra will get cancelled. I'll have what left? Sin t will be here, minus sin. What is this? 2 sin t by 2 cos t by 2. How much is that? Sin t. Please check here. 2 sin cos is simply sin 2. Sin, what is this going to be? Please see here. This will transform into, a will remain as it is, minus sin t will remain as it is. Please check. Okay. Now this will become plus 1 by sin 2 upon t by 2. Yes or no? Please have it. Please pay attention over here. यहाँ देखिए t by 2. Okay. 2 sin cos means sin 2 times of the same angle. So 2 sin of 2 t by 2. 2 and 2 will cancel. So simply sin t. Okay. Now what I have? Dx by dt as, I have dx by dt as a as it is minus sin t plus, what is it? 1 upon sin t. Yes or no? Yes or no? Yes. So what does this become? Please check here. A will be what, bacha? Minus sin square t plus 1 upon what? Sin t. Yes or no? Yes. How much is this? Please check. A cos square t upon sin t. Yes or no? Yes. How much is this? Please check. A how much is this? Cos square t upon sin t will be simply what? Yeah, I can keep it like this also. A cos square, I can keep it like this also. No problem. A cos square t upon sin t. This is my dx by dt. Okay. 1 minus sin square is cos square. So a cos square t upon sin t. Okay. Chaliye. Again same do for a sin t. Y equals to a sin t. Y equals to a sin t. I have differentiated. I'll get dy by dt equals to a times of cos t or not. Yes. What I'm looking for? What I'm looking for? Please check here. I'm looking for dy by dx. What is my dy by dx? Dx, this thing first, a cos t, okay, this is cos bacha, a cos t upon this thing, a cos square t upon sin t. Yes, yes, a and a goes out, one cos will go with this. I'll have what? The sign will go up, sin t by cos t. How much is that? Tan t. This is my dy by dx. Yes. Okay. Simple. Very, very simple. Please check. Differentiating of this is dy by dt. Dx by dt we got at this statement. Over here dx by dt I got it at this statement. The ratio dy by dx upon dy by dx equals to dy by dt upon dx by dt. Cancelled cos and cos, a and a. I got sin by cos, which is tan. Simple. Moving on. Chaliye. Again, sin square x. Differentiate sin square x with e cos x. With e cos x. Okay. Okay. So let's take this as p and this as q. Okay. So what are they asking basically? They are asking us to find dp by dq. How will I write it? dp by dx upon dq by dx. This is what? Differentiating a variable with respect to another variable. Okay. Sorry, another function. Alright. So again what I'm using? Parametric form only. So do the first one first. P is sin square x. So dp by dx will be what bacha? 2 sin x. Okay. 2 sin x, please here. 2 sin x cos x. Same way. For this what I'll have? dq by dx. I'll have e power cos x, it should be, right? E power cos x, not e cos x. It should be e power cos x. Forgive me. E power cos x. Cos theta, no? Cos x. It should be e power cos x. Okay. So it will become what? Same. E power cos x will remain as it is. Then will become what? Minus sin x. Correct, right? I have to use chain rule. E power cos x will be same as it is. And then I have to do for cos, it will become minus sin. I'm looking for what? dp by dx by dq by dx. What's dp by dx? Please check here. 2 sin x cos x. 2 sin x cos x. And what is this? Minus minus e power cos x sin x. Gets out. What is the final answer? Minus 2 cos x upon e power cos x. My final answer is this. This is my final answer. Please check here. Differentiation of the first one with respect to the second function. Final answer. Differentiation of this with respect to this. 2 sin x cos x upon minus e cos x sin x. Sin x goes out. 2 minus 2 cos x upon e power cos x. Simple. Very, very simple. Okay. We are coming very close to completing the session. We are on 35th question. Okay. Now, the last topic which is there, finding the second order derivative. What is this, bacha? So first we find the first derivative. So dy by dx. When differentiate that part again. So basically what I'm trying to say here is, first this function given as this something y equal to something is given. So what's the first derivative? You write here this. Let's say y equal to fx is given. So you write this as dy by dx for the first one as f dash of x or not. Yes. Next one you're going to do again, differentiating the same thing with what? X for the second time. Means I'll differentiate dy by dx. I'll differentiate dy by dx. This will be simply what? F double dash of x. Okay. So this will become what? D square y upon dx square is my way of writing it, or I can write it as f double dash of x also. So either I write it like this or write it like this. Same thing. Okay. Chaliye. So function is given, find the second derivative. So let's first we have to find what? First derivative. So y dash will be what, bacha? Product tool have to use. Product tool means e power x keep as it is. Sin power 5x will be what? Cos power 5x multiplied with what, bacha? 5. Yes. I kept ex as it is. Sin will be cos, 5x will be 5 plus sin. E power x will keep as it is. Okay. Now what will this be? Sin x will be simply like this. Sorry. I differentiated this part over here, then I differentiated e power x. E power x remains same, no? So no problems. E power x I'll take it common. What I've left now? I have what? I have 5 cos 5x plus sin 5x. Yes, correct. Now I have to differentiate it again because this is what? Derivative number 1. Okay. I have to find what? Second derivative. So y double dash we have to find it out, bacha. So what we're gonna do? Again differentiate it. We'll have to use product rule again. So use this. I'll keep this e power x as it is. Okay. And differentiate this part. It'll be what? 5 will be as it is. This will become what? Minus sin 5x with 5 again. Okay. And this will be what? Simply cos 5x with one of the 5. Now I have to do what? Keep a plus sign and keep this thing as it is. What is it? 5 cos x cos of 5x plus sin 5x as it is, and differentiate e power x, which will remain again the same. So this is my second derivative. Take e power x common now. What I have left, please check. I have here 5 into 5. So 25 with a minus sign. Minus sign is there, right? 25, 1 second. I'll rewrite this. Please follow. 5 into 5, so 25 with a minus sign, so minus 25, and sin 5x. What is it? Sin 5x. Okay. Now what is this? 5 times of plus 5 times of cos 5x. I'm taking e power x common, so this will be again added over here, plus 5 cos x plus 5 cos 5x. What is left? Plus sin 5x plus sin 5x. This is everything. Okay. Now see here, if I'm writing the final answer, e power x is common. Please check. Minus 25 plus. So first let me just add this. 5 cos 5x plus 5 cos 5x. Simply what? 10 cos 5x. 5 cos 5x plus 5 cos 5x is 10 cos 5x. Sin 5x minus 25. So minus 24 sin 5x. My final answer. This is my final answer. Second derivative, bacha. Second derivative. Okay. First we differentiate it like this and get it over here. How we do it? Take the differentiation of the first derivative. Take the differentiation of the first derivative. You're gonna get the second derivative written like this, or you can also write like y double dash. Write like y double dash. चलिए आगे बढ़ते हैं. Log of log x. Simple. Very, very simple. Y equals to log of log x. Take this. No problem. Y dash will be what, bacha? 1 upon log x. Then I have to do what? Chain rule. For I did for this log. So log x is coming down. For this will be 1 upon x. What is my answer? 1 upon x log x. 1 upon x log x is my what? Is my differentiation from the first derivative. Okay. So I can use what? I can use quotient rule, or I can use this as x log x power minus 1 also. I can use the polynomial also. But let me use the quotient rule. So what is going to be my second derivative? Differentiation of 1 upon x log x. Please check here. Quotient rule, right? So 1 will be what, bacha? Differentiation of 1 will be 0. 0 times of what? X log x. Please see this. I am using quotient rule. Differentiate 1, 0. Keep this as it is. So x log x. What will come here? Minus sign. Keep 1 as it is and differentiate what? Differentiate x log x. And divide whole thing by x log x the whole square. X log x the whole square. Yes. Okay. What is my this thing gonna look like again? Please check. Okay, please check. So this will be simply 0. I don't have to write this. Minus. I have to use what? I have to use product rule now. So keep this as x, and this will be 1 by x for log x. Okay. Now I'm gonna keep x for I'm gonna do for x, so it will be 1, and it will be simply log x. Okay. My final answer will be this only. X log x the whole square. So see here, this and this goes out. What is my final answer? My final answer is minus sign outside. This will become 1 plus log x, okay, upon x log x the whole square. Please check. This will become 1, minus sign is outside, log x upon x log x the whole square. This is my final answer. This is my final answer. For what? Second derivative. Okay. No biggie, no big deal in the second derivative. Simple steps. Okay. Nothing else is there, bacha. 37th one. Okay, this is your homework. Please do this. Please do this question, right? Same thing. First do for sine, then do for log. Okay. Then do whatever you're gonna get. I'll do till first derivative. So I'll get what? Tell me. I'll get cos of log x. Okay. Times of 1 by x is my first derivative. What is my first derivative? Cos log x upon x. Now you have to find the y double derivative. What are you going to use? Use the quotient rule and then use the product rule also. So quotient rule for these two times. Okay, not quotient, not the product, chain rule. I mean chain rule. First you have to use the quotient rule, then you have to use what? Chain rule. Quotient rule for this fraction, okay, and then use the chain rule for cos of log x. Okay, solve this answer and comment below your comment your answer. Okay, chali, homework. Next problem. Okay, now this is application of second derivative. First few questions we solved to see how we solve the questions on second derivative. We are coming close to it. Okay, so I think now another 10 minutes and then session will be over. Okay, so I think we have 2 questions left. Let's solve this. One of them I will do, one I'll give you as homework, because I've taken this category of question only 2. So one I will solve, other question you have to solve by yourself. So please pay complete attention on the screen right now. So what is it? Y equal to tan inverse of x the whole square is the given function. This is the given function. We have to find out this condition. We have to prove this condition. Okay. Now please understand, y2 means y double derivative, and y1 means y derivative. Okay, this you know, right? Y dash dy by dx or y1, same thing means for a first derivative. Y double dash or y2 or d square by y, d square y upon dx square is all same for second derivative. So same thing is there. Okay, chaliye, let's solve the first one. First one we'll solve. Okay, so we'll take the first derivative first. Please check how will that look like. I have a space. Yes, I have a space. So y dash will look like this, or let me write it as y1, y1, because they are asking in the equation. Okay, we have to prove this equation. So let me do it for y1. What is my y1 bacha? Please check. Y1 is going to be 2 will come in front first. I'll be tan inverse of x, the power 2 minus 1. Yes or no? N into x power n minus 1. And for I have to do for what? Tan inverse x also. It will become what? 1 upon 1 plus x square. What is my, can you simplify this? It will be 2 tan inverse of x upon 1 plus x square. Yes or no? Yes. Now what is the next thing? We have to do what? Y2 also. Y2 is what? Second order derivative. So let me do it from here only. So y2 will be what, bacha, tell me? I have to use the what? I have to use the quotient rule. So I'm going to use it for the first numerator. 2 will be a constant. I can keep it outside. 2 is a constant. I can keep it outside. For tan inverse, what I'm going to get? Okay, I have written as 11 there. It's 1. Okay. Okay. So I'm going to get it as 1 upon, for tan inverse, I'm going to get it as 1 upon x square. Okay. And then what? I'll keep the denominator as it is. Yes, please see. I have done for the tan inverse of x, the differentiation, 1 upon x square, and denominator will be kept as it is with a minus sign because I'm using a quotient rule. And then I'll keep what? Tan inverse of x as it is. Yes. And I'll do for this part, 1 plus x square will be what? 0 plus 2x. Yes. And then whole thing divided by whole square of denominator. Whole square of denominator. Yes. Please check. Please check. So now I'm getting y2 as, please check. Okay. Let me just write it here. Not y2 equals to 2 times of, please check. This is getting cancelled. Okay, 1 plus x square, 1 plus x square. I'll change the ink sign. Please check. Getting cancelled. Okay. Now what next? Simply 1 is there. And what is this? Minus 2x tan inverse of x or not? Yes. Minus 2x tan inverse of x or not? Yes. So what is this? Please check. What is this? Upon, whole thing upon actually, 1 plus x square, 1 plus x square, the whole square. Okay, the whole square is there. Okay, now what I'm going to do, I'll bring this whole square on this side. I'll bring this whole square on this side. So what I'm going to get? y2 times of 1 plus x square the whole square. Please check. I'm bringing this denominator on this side. Okay, now you please relate this. y2 times of this thing has come. This thing has come. What is left now? Equal to 2 times of 1 minus, please check, 1 minus 2x tan inverse of x. Write it here. 2x tan inverse of x. Okay. Now expand this. I'll get 2 minus 4x tan inverse of x. Am I right? Now bring this 4x over here. I get y2 times of 1 plus x square. Okay. The whole square plus 4x, okay, times of tan inverse of x equals to 2. Correct? Yes. 4x of tan inverse of x equals to 2. Now please check. What is my y1 value? What is my y1 value? This is my y1 value. Yes or no? Yes. So let me write the y1 value again here. My y1 value is 2 tan inverse of x upon 1 plus x square. Okay, 1 plus x square. So from here I want what value? I want 4x tan inverse of x. How am I going to get? Please check. So I'll multiply this over here. y1 times of 1 plus x square equals to what? 2 tan inverse of x or not? What value I want? I want 4x tan inverse of x. So from here, if I cross multiply, I get 2 tan inverse of x as y1, 1 plus x square. But I want 4x, only 2 is there. I'll multiply what here? 2 tan inverse of x with what? 2x. Then I get what? 2 times of 2 is 4 and x is there. I have to multiply this thing over here also. y1, 1 plus x square with what? With 2x. With the 2x I have to multiply here also, not visible. Let me write it little bigger and little visible. So I'm trying to modify this equation in the given condition that they're asking. So let's write it here. y1 plus 1 plus x square times of 2x, sir. How? I'm multiplying 2x on both sides. Why? You'll see. What will this become? This will become 4x tan inverse of x. This will become 4x tan inverse of x. Okay. And what will this become? Please check here. This will become 2x 1 plus x square times of y1. Please check. 2x 1 plus x square times of y1. So let's replace this here. y2 times of 1 plus x square the whole square. This thing can be written in this form, plus 2x times of 1 plus x square y1 equals to 2. Equals to 2. Please cross check. y2 1 plus x square the whole square. y2 1 plus x square the whole square. Next, 2x 1 plus x square times of y1. Okay. 2x 1 plus x square times y1. Next, equals to 2. Equals to 2. So what we have done now? We have verified the given statement. Okay. Or we have not verified actually. We have proved the given statement. So we can write here. Favorite word, sir. Hence proved. Hence proved. Yes. Condition what they gave. I found a derivative. What derivative? First one and second one, and got the result as this after modification. What modification I did? I did for this. For y1 I did a modification. For 4x tan inverse of x, I substituted that value in terms of y1 and I got the resulting answer that they were looking for. Okay, please have a look. Okay, please have a look. I hope this is visible. Okay. Yes. Alright, you can see the questions has been asked so many times. So it means it's a very good question. Okay, it means and if this is coming again, come for 5 marks. Look, the thing is this chapter has a heavy weightage. If the question is coming from this chapter, no, only for MCQs, if the differentiation is very straightforward based upon the directly formulas, directly rules, then they will give you for 1 mark like that, 1 mark or 2 mark, simple differentiation. Otherwise, okay, or if they are asking continuous function, like whether the function given is continuous or not, simple question is given, then 1 mark. Otherwise 3 mark, 4 mark, 5 mark question you can expect from this category. You'll have a higher weightage over here. Last problem of the day. Okay, last problem of the day, sir. Okay, same thing, exact same thing. I can write this as y2 minus m plus n times of y1 plus what? mny equal to 0. We have to prove this. We have to prove this. For this, what we have to do? Find y2 and y1. Okay, this will be your homework. Simple question. This is very simple question. Why simple, sir? Because the exponential function does not change, keeps as it is. Okay, but I'll give you some hint. I'll solve up to some extent. Please check. So I will solve y1 first. Let me solve y1 for you. What will be this y1? y1 will be a as it is, e power mx will be as it is, and then I'll get what? One small m here. I'll keep b as it is, e power nx will be as it is, I'll get n here. Okay, so what is my simplified version? a m e power mx plus b n e power nx. Yes or no? Yes, sir. What about y2, bacha? y2 is what? Second derivative. Differentiate again. I'll keep a m as it is. This will be what? E power mx as it is, and again I'll get what? Differentiation of mx will be m. Check here. E power mx differentiation is e power mx. I will differentiate using chain rule for mx also. I get m plus. Not looking like m. Let me rewrite this part. So m. Okay. Chaliye. What will this be? b n will be as it is. E power nx differentiation will be e power nx only, and for nx I'll get what? An n. What I'm getting now? a m. This m will come. So a m square e power mx, and what I'm gonna get here? Plus b n and n. So b n square e power nx. This is my y2. My y1 is here. y2 is here. Simply put this value over here, multiply with m plus n. Simple, very simple linear equation multiplication. You'll get the RHS to be 0. So take the LHS. What are you gonna do now? Take the LHS. Okay, take the LHS, and in the LHS part use y2 and y1 value. Okay, what is LHS? y2 minus m plus n y1 m plus n y1 plus m and y plus m and y. So take the LHS, okay, and put the value of y2 here and y1 here. What are the values, bacha? Check here. Y2 is this, y1 is this. Put the values there. You'll get the answer to be equal to what? 0. You'll say what? This is equal to RHS, hence proved. Okay. So this is your homework problem. This is your homework problem. Please have a look. I hope this is visible. Again, if this comes, it'll be for 4 marks, 5 marks, you can expect. Okay. So with this, I have completed your in-demand chapter, which is continuity and differentiability. Okay. I hope honestly you have gone through all the questions, stayed through entire video, not skipped any part. Okay. Because we are completing, we are doing this work for you only. You have asked for it. Midterm revision, sir, revision karwa dijiye. Okay. I have come up on the session and completed your entire chapter in one shot. Okay. Solved 39 questions. If you solve all these questions, okay, whether the question in the midterm is coming same or not, coming similar or not, but think about it. If you solve 39 questions of differentiation only, okay, of all the varieties, very simple to very difficult kind, then obviously you have learned the concepts through the questions and you can crack any question coming in your midterm examination. I'm going to give you all the best for this chapter. Okay, make sure that you solve all the questions again and again. If you're not getting this question, solve it again and again. Okay, twice, thrice, whatever it is, until unless you feel confident in the concept. Okay, so with this I would like to end the session. I hope you have enjoyed the session. I hope this was helpful. Keep working hard. Your midterm is around the corner. Keep working hard and keep positivity around yourself. Have some good music, play some sports whenever you can. If you are having some time, very less time, do yoga, do meditation, and keep yourself positive all the time. Okay, whenever you can. If not all the time, whenever you can. With this, I will say goodbye. Take care. Tata. See you in the next session. Bye bye.